Hello, let's sir join. Can you hear? Hello. Our head professor Jyotinder. Hello.
Yes, sir.
Can you speak?
Professor Nandi, I am audible? Yes.
Whatever. No problem. Okay. Fine.
No.
We'll start a little another 5 minutes.
Okay, fine.
Murthy,
Sir,
when will
sir, 5 minutes, sir. Maybe another 50 members may join immediately within 5 minutes. Everybody is
okay.
thinking that 10 o'clock that
Okay,
we said given schedule, no?
okay, 10 o'clock will
Okay,
start.
okay, sir.
Dotted.
Yes, sir. Already there are 150 people are there, sir. Maybe joining, sir, increasing every day.
Ranbir, can you speak now? Ranbir?
Is it audible now?
Audible, audible.
Oh, okay. Yeah, I think it's fine.
Oh, it's fine.
Yes,
Murthy,
yes, sir.
can you start now?
Yes, sir.
Huh?
Yes, sir. Please, sir.
Jotin, can you speak? Is it audible?
Hello.
No
Is it
problem.
audible?
We'll start it. We can start.
Okay. All right.
Okay, Ranbir, take care of it. Ranbir, start.
Okay. A very good morning and warm welcome to all the panelists, organizers, and the participants in this e-faculty training program on machine learning techniques for social media analytics and information perspective. My name is Sanasam Ranbir Singh. I am a faculty in the Department of Computer Science and Engineering, IIT Guwahati. I am one of the coordinator. So today's session I will be coordinating. So this course is organized by the Department of Computer Science and Engineering, IIT Guwahati, in association with ISEA 2. As we all know that social media analytics is a vast area and it is not practically possible to cover all the aspects in this 1 week program. So this program is basically focusing on learning basic machine learning techniques and a few of its application on social media data from the information security perspective. And this program is like a first step in realizing application of machine learning in the information security application on social media. So this course consists of about 12 hours of theory sessions and 8 hours of lab sessions from the experts in academia and industry. At the end of this course, you will be learning different machine learning methods and a few of their practical applications. So with this basic understanding on machine learning and general applications, we plan to conduct more specialized courses on information security application using advanced machine learning technique in future. But idea of this course is, say, starting with the basic machine learning techniques. So with these few words, I once again welcome all the participants, panelists, and in this program, and we wish you all a very warm and fruitful week ahead. Thank you very much. So with these few words, I would like to request Professor Jatin Deka, Head of the Department of Computer Science and Engineering, IIT Guwahati, to share a few words. Sir.
Okay, thank you, Ranbir. Good morning and welcome everybody to this e-faculty training program on machine learning technologies for social media analytics. I am Jatindra Kumar Deka, Head of the Department of Computer Science and Engineering Department of IIT Guwahati. Okay, already Professor Ranbir Singh has already mentioned what you are going to get in this particular training program. Okay. Now, on the other hand, you just see, in earlier, we have conducted a lot of such type of training program, and people used to come to our department or they visit IIT Guwahati, and in person, we are conducting our session. But this is slightly different. We are doing in online mode. And all of you know that this is going to happen due to our COVID-19. So, though it is disturbing the whole world, but still we are moving to another dimension where we are going to conduct such type of live session in online mode. Okay. Earlier we never think about it. So due to this reason, I think we are getting a lot of advantages. Now we have seen that around 200 participants are already joined in this particular event. In physical mode, we could hardly accommodate 40 to 50 participants. So we are reaching out to the more people. So this is the advantage that we are getting it. But if you look into the situation in the month of March, we are not ready at all for this particular online mode. Very sparse where some of the people are using this particular online meeting or video conferencing. But currently it becomes a norm. Okay. So in this particular training program, I think you are going to get some idea about the machine learning tools. That machine learning tools will be used for social media analytics. Okay. So that means we are having a lot of information, lot of data in social media platform, how to analyze those particular data and how to get meaningful information. We are going to look into it. And for that, I think we are going to use machine learning techniques. And I think in this particular 1 week or 5 days program, you are going to get some idea about those particular tools and techniques like machine learning, how to analyze the data that are available in the social media, and special emphasis will be given on the security aspect of those particular data. So I hope that this will be very useful for all of you. But as such, I don't have much knowledge about machine learning. I don't have much interaction in social media. But as a user, I can give you some idea that what is my feeling is earlier and today. When this lockdown started and people says that, and everywhere in every organization says that now we are going for the mode of work from home. When people are starting work from home, if you see, or at least I have encountered in the month of March and April, there are a lot of cartoons are appearing in the social media platform like Facebook and other places like that. Is just people are switching on their video, or joining into the team meetings or maybe webinar meetings, and after that they are doing some other household activities. So such type of cartoons were there. It was very rampant in that beginning point because just people are switching from physical mode to the online mode, and at that time we are not ready. But now today in August, if you say in 5 years or 5 months, it becomes a norm that we have to work in online, and such type of cartoons are not coming at all, at least in my world. Okay, so this is the mindset actually. Initially, we thought that it cannot be done. Now we are accustomed to it and we are doing it now. So this is the way that shifting is happening, and maybe in future that will be the only way that we are going to do in online mode. And I hope that all the participants are going to get some fruitful information, fruitful knowledge after attending this particular webinar or e-faculty training program. Wish you all the best. With these few words, I conclude my talk and switch back to Ranbir.
Yeah, thank you, sir, for your very insightful and thoughtful feedback and for sharing the ideas in this session. So next, I would like to request A.S. Murthy. So he is Associate Director of CDEC Hyderabad and coordinator of ISEA project. So I request Murthy sir to share a few words about ISEA project. Murthy sir, I think you need to unmute your mic.
Thank you, Ranbir, Dr. Ranbir, conducting such a kind of, I think it is the first time such kind of workshop or training on machine learning technology, social media analytics. So there are more than 200 people are attending directly on online with this platform. However, there are more than 100 people are joining through our InfoSecure Awareness Live and also in the YouTube Live. So I'm welcoming warm welcome to all participants for this training. It is a very good opportunity from IIT Guwahati as part of Information Security Education Awareness Project. As I would like to tell about that, what is exactly this ISEA project? So basically, keeping in view of the pervasive nature and the impact of cybersecurity on walks of all our life, whether it could be an economic and social, government of India has identified this project as one of the major thrust area for launching various cybersecurity educational training and awareness programs. So one of the key element essential for information security is availability of right kind of qualified and well-trained human resources. So that is what this program is introduced with, right from education onwards and taking up to research and development and developing indigenous solutions. This is what thought process where Professor Nandi is one of the important key person from the right from 2005 onwards involved in this program, where this at present is this program is under second phase with the objective of generation of core research manpower to undertake basic and fundamental researches as part of information security research and resource development centers. Generally, we call it as a ISRDCs. These ISRDCs is majorly working on research, generating the core research manpower at academic institutes. So we have 4 ISRDs at IIT Madras, IIT Bangalore, IIT Guwahati, and IIT Mumbai. However, there are resource centers where there are 7 resource centers like IIT Roorkee, IIT Kharagpur, NIT, NIT Jaipur, NIT Surat, NIT Suratkal, NIT Warangal. These are the some of the resource center which helps, and totally there are 52 institutes together joining along with the technical universities like JNTU, West Bengal Technical University, Gujarat Technical University, Rajiv Gandhi Technical University. So these are the university together with the target of 1 lakh um, participants in this program, where we almost achieving around 2 lakh because of the support of the technical universities. So we also introduced kind of in a cybersecurity curriculum with around 57 courses, which we recommended. And most of the institutes are consider this curriculum as a basic with the in view of their in keeping in view of the career path. So those who are interested into research, what kind of they select. Similarly, those who are interested to go to operation side, what kind of courses at academic level itself we created, and accordingly we are also encouraging to develop courses with supporting of these institutes. So with this, there is a training program which we are also planned government official training, where which we have a target of 1,300 people per annum. But recently, IIT Guwahati is also supported with the various in association with Penetration Academy, where we conducted more than 300 people trained on this as part of this program. And similarly, the CDAC and NILIT centers are also conducting as many as trainings with respect to government official training. And the third part program is awareness. It's a mass awareness where we continuously delivering that as much as reach to that this one, and we are also planning to reach every user through various mechanisms by conducting by associating with policies and respective things. So these are the briefly this is about IC program, and we are very happy that the IIT Guwahati is come up with such kind of program to give a kind of overview of the with respect to the machine learning technologies and social media analytics. So this is one of the topic which burning topic which is required as. So I thank especially Professor Jatindra Kumar Dekha for supporting such kind of activity, and of course, so our mentor and guru. So to Professor Veer. Thank you.
Thank you, Murthy sir. So with this, I will try to, I will invite Professor Nandi. But before inviting Professor Nandi, I would like to share that today we have 4 sessions, and the first session will also be taken by Professor Nandi. So I would like to request Professor Nandi to briefly close the session and start his sessions. So before that, let me take the privilege to introduce Professor Nandi. But as such, he does not need any introduction, but just to kind of follow the formalities. So let me try to introduce him. Uh, so Professor Nandi is presently professor of the Department of Engineering. He is also associated with CLST, and he was the former head of the department. Professor Nandi is a recipient of ISEA and the IET Fellow. He held various administrative positions in the past, including Deputy Director of IIT Guwahati. His area works in various areas, but few of the area includes networks, computer and network security, distributed computing, machine learning and data mining, BLSI design and testing, computational linguistics. He already produced about 20 PhD scholars and published more than 350 research papers, and associated with more than 25 sponsored research projects. So he has a vast experience in administration, research, and executing various research projects. So it is indeed fortunate for us to have him as one of the resource persons. Sir, with this, I would like to hand over to you, and please briefly close the sessions and start the your sessions on machine learning applications in information security. Sir.
Thank you, Ranbir. Good morning, all panelists and all participants. I have customary to say few words about our ISEA program. We started in 2004-5. We completed the first page. We are in second page. We are end of the second page, and we have to go carry forward towards the third page. Maybe third page will start next year. And for the third page, to create the manpower who can carry forward the third page. So basic philosophy behind is that we did some task in the first page. We created some manpower, credit and training and capacity building. Second page, we started our added into the capacity building, awareness and everything. Next page, we are targeting for research, innovations, and Atmanirbhar or self-reliant. So we page where we have to go forward and make India in information security domain one of the potential country to contribute to the whole world, including our own safekeeping of our data, privacy, secrecy, and everything. One of the venture today we are doing is, or this week we are doing social media related, which is one of the important topic. Look into it, how we'll do, what level we can do, that time to come. But we are targeting that all participants, all faculty member, research, whoever participating in this program, be aware of this is one of the important requirement for our phase 3, one issue, and government of India, another issue, and protecting India issue. So our target is to create environment for learning, environment for contributing to the need of India and need of the society. So it is one of the small gesture for this. Hope coming five days, including today, we will learn something and we can contribute to society as a whole. By the way, we are habituated with the process one-to-one interactions, but here it's monologues, one-sided interactions. But we have no other choice to learn and make our knowledge as best as possible present scenario. With this, conclude this inaugural session. Within 1 or 2 minutes, we will start the first session where I will come as a speaker. I thank everyone to participating in the inaugurations and specifically CDAC helping this program to be reaching to each and every participant. Thank you. Murthy, we can switch over to Ranbir. Dr. Ranbir.
Sir,
Now we'll
thank
switch
you,
over to the. Okay.
Yeah,
Okay,
thank you,
fine.
sir, for this inaugural session, for closing this inaugural session. So, sir, should we start a session now or take some break?
1 minute.
1 minute break. Okay.
1 minute.
So we need sir, PPT. Yes.
You are able to see?
Sir, yes.
Now you can correct.
Yeah, we can see your screen and.
Okay, then I can start within. Okay. Let me switch off my video, otherwise it will have a problem. So within 1 minute we are starting.
So as we are waiting for Professor Nandi, I just want to brief to the participant what are the tentative programs for today's. So in the morning, we will have 2 sessions. So first session will be from Professor Nandi. This is a brief high-level overview of various machine learning application in information security. Then there will be a brief, very low-level introductions of machine learning, understanding of machine learning technique, what is machine learning and definitions of machine learning and so on from myself. Then in the second half, we will have 2 sessions. One session is say brief introduction of NLP application in social media data from Dr. Ashish Anand, and then he will be followed by Dr. Saradi with the brief introduction of various text mining application in social media data. So today we have kept say introductory sessions to kind of 3 different say verticals, and in the following sessions we'll be say briefly introducing some of the advanced applications such as technical detection,
Okay.
detection,
So
and so on.
let us start. Let us start.
Yeah. So
Okay.
with this brief introduction, I'm handing over to Professor Nandi. Thank you, sir.
Okay. So Hope everyone able to see my slides and able to see me. Sorry, able to see my. So my topic is machine learning in information security. Okay. So basically, in our research on information security in IIT Guwahati, we have a team of faculty members, and with research scholar, we are leading the capability in cyber security. We are also developing some defense mechanism. We are working with industry to provide security solutions related to cyber. So if you look into the capabilities in IIT Guwahati at part from system security, data security, and application security point of view, if we look into this, we are IoT security. This is the area. We are working on network security, software defined network, network function virtualization security. This area we are working. We are working in the data security domain, insider attack detection, that is intrusion detections and others. Social network security and security analytics, these are the today's topic. This social media analytics, we are working on this, specifically this. We are using machine learning for cyber and threat predictions. So at present, this we are working on this, and if you go in details, you will find several people are working, and we have a machine learning group. Quite a good number of faculty members are working in machine learning groups. Before I reach to anything, in machine learning, one of the important things we have to remember is that to look into the any data or any system, we have to secure it. Three things we have to come in mind. That is data, and data, based on data we model it, and based on model the new data or new things, we try to find some outcome. So any machine learning technique, generic one, may not directly applicable to any special domain. So data is domain specific. Considering data is domain specific, we have to build a model which suit to the data, and accordingly, based on our objective, the model will give the results. So we have three very important parts in block level, but it's not three, more than three. So first, let us look into the data. I want to spend some time here because data is the gold mine for us in machine learning domain or application of machine learning domain. Usually, including the social media data or big data, I say that it's not big, it's a huge and huge and huge or the data. Sometimes we get whole data to process it, but it's a huge data we cannot process. Sometimes we get a sample data like Twitter. If we try to get the Twitter data, we get usually 1% of the tweet data, or we can go up to 10%, 100% getting is required lot of. So, and if you go to the work, you will also find 10 Gbps connections. If I have to process everything, 10 or 40 Gbps or 100 Gbps, if I try to process all data, it's not possible. And not a single service provider will provide whole data. So we have to think of what will be the samples, how to sample, and what sample space I want to use for my machine learning techniques. So this is one of the important criteria. You have to remember that big data, whole data may not be available. If available, we cannot process it, and they require some level of sampling or subset of the data to be utilized for our operations. As a result, data is also incomplete. The next portion is data is incomplete. For example, if I collect some data from social media, Twitter, some group or some activity, same group may be overlapping with another group, or if you look into the computer network, I collect data from one router or one switch or multiple switch, but all I'll get a portion of the data, and as a whole, I don't have option to use. I don't have option to get the complete information. That is a very, very important point. So we have to get data from multi-point and combining these, we'll put it in together to make it as complete as possible. So our data is incomplete, but we have to combine them as completeness as possible. Third, important one, very, very important one, data are unbalanced or skewed. So basically, why unbalanced? The attacker, but the rumor creator or the what is called communal riot creator, they create at one instant of time and very difficult to find it when they have done it. So the attack informations or the informations are very, very less invisible, mainly the normal informations. So we have normal or venial, and you have abnormal or attacks or some mischiefs or hack. If you look into these two data in the whole data sets, you will find the data are very small, and once in a blue moon it appears, and effect is visible, but when it is happened, finding it's not that easy. So data are unbalanced, skewed, and if I do little bit big data point of view, I have to capture the sample to process it. Then it is coming the small sample size problem, which is a big research topic. How do I sample that I should not miss the abnormal or attack data while preparing my sample space for working in machine learning, because my big data is unbalanced. So next, every data has a lifetime. We faculty members, we try to go give benchmark data. So those who are working in network, they go to the KDD CUP datasets, and the old 80, 90, that 95 or so, that data has no applicability now. So every time the data is coming, data has a lifetime, and after that, lot of things are changed. Those data, if I use it, I cannot process it. So all data has a lifetime, and data is usually available in terms of stream. So we have to come up with some technique which can take the streaming data and do it. Next, that context sensitive. It is very, very important in social media analytics. Some point of time, some discussions, some religious discussions, data is normal. But some other point of view, religious something is totally different, and it leads to riot and everything. So if you look into the data, data is really context sensitive. And if you go to the machine NLP, natural language processing, that word has different meaning in different context. So data is context sensitive. So our system has to develop based on this context sensitive issues also. And obviously social media data is time series. It has a timestamp in it, and time is very, very important. When it started, when it ended, what is happened, all the time series analysis is one of the important requirements for the social media data. So we cannot forget social media data is without time. time is a very, very important, and every things I have to look into it. Next, encrypted and compressed. Data can go unencrypted. Unencrypted data anyone can read. Its life is easier. When it comes to compressed data and encrypted data, it is really tough to find it what is actually going on inside if they are using latest encrypted techniques, encryption techniques. So it is a big challenge in social media analytics or any area where encryption is one of the fundamental upstream. So it is one. By the way, data if it is compressed or data if it is encrypted, it is very difficult to distinguish it is encrypted or compressed in a communication media over the network. So one challenge is how to find the data is compressed or data is encrypted. If someone can find it, data is compressed or encrypted, then half of the job will be done, because compress means compression algorithm, we can use it and get the data. And encryption, then we have to start for this. Last and most important is multimodal. Today's scenario, text, audio, video, and image, image captions, image, what is called forgery, all these things, if you look into it, if we try to conclude only on text-based analytics, may not give up to 100% or up to a certain level. But if I use in social media, blogs, and other places, I should use text, I should use video in the context of that. If someone has used the video or morphed the video, and captions of the video, image, and if audio is available, all together, if we come up with some method, then definitely data, the system will be more powerful. So data is multimodal, we have to process it. Now coming back to, again, same block diagram, data, model, and result. As discussed last slide, data, we try to get the data at a certain form, understanding. Based on the data, we build one model, maybe deep model, that CNN or by LSTM or transformer, depends on the need. And after the model, with future data, we'll try to check that it is satisfying the outcome. But when one organization purchase one model, so system which build around the data at present, and model is nicely working, the system is not working, suddenly is found that tomorrow or day after tomorrow, the data has changed because operating system changed, application changed, the way of attacking change, way of communication change. So my data definitely will be different. Data is dynamic and the model may fail. So what people try to do, tune the data so that it will monitor to suit to the model. So one group are working how to tune the data to suit the model. Why you will do? Because big investment cannot be got wastage. So people try to tune the data so that model and work. Some groups say that no, I will not tune the model. Sorry, data. I can tune the model. So earlier model, I will tune some parameter or training I will do. Again, I will do all these things. May change from one model to another model, but it's a costly, but it is possible. Tuning is one of the important. So one group research is working on data tuning. Obviously, most of us working in modeling based on the data. And sometimes we get the result. For example, if you look into the today's firewall or today's network access control or anything, generate huge lot of data. And some of the data is useful, are not useful. So what we do, we run another filter or something where will result will by putting one filter to extract some of the result which is useful for us. So if you look into as a whole, the machine learning group system in place, either they tune the data or tune the model or filter the result or tune the result to satisfy the requirement. So all are going in and around this. So whole things are fully built around. Now I'll go to the based on this, how AI and ML will be useful for our day-to-day life. Obviously, improve speed of reasoning. AI ML is obviously speed of reasoning because use process very quick. Improve speed of reactions. Very quick we can get the result instead of manually checking each and every records. Machine can easily find it, the latency obviously will be less. Scale of data as it is huge, AI ML technique definitely process huge data with efficient way. Obviously, scale personals, force multiplier, and pattern and connection, that's the last one, is very, very important one, which human cannot find it. AI ML techniques definitely can find it. So missing informations or data mining or information mining in a particular way, it is possible in AI ML techniques, which human cannot find it. I would skip this one because time is one of the factors. So one of the information we have to look into this AI ML failure is that there have been many reports on AI ML showing gender bias or racial bias. Why? Because most of the data what we use either incomplete or the sample size problem or some data collection from where we have collected, the region bias or something which leads to AIML failure. But please remember, AIML cannot failure, it may not be failure, proper data and proper we should take on the data. So, for example, in of incorrect face detection, that is a failure. One person's camouflage is another. Fatality involving self-driving car sometimes wrongly identify something and accident can happen. Wrong recommendation and prediction field like healthcare and sports. So all these things are very, very important one. So what I wanted to say is a very important slide, this one. Two aspects of AI and security is security. Similarly, security enable AI. What it means? We can use AI technique in security. That is, AI enables the security. Similarly, AI/ML techniques should was no one can fool or no one can do anything that AI/ML technique give wrong result. So that's why security or AI. So security enables better AI. That means the system we develop based on AI should have integrity or correct result. You may have heard about adversarial machine learning. We have to remember there is such things exist. I'll come few more slides after this. We should have confidence in the privacy. So machine learning techniques should not create leakage of users' private data. Preventing misuse of AI, using AI, some security attacks can be possible. So one goes with others. We cannot separate it one with others. Let us look into attack AI. Attack AI is basically AI in the presence of attacker. Attacker is available. AI, we are running that scenario. Attacker can do learning system do not produce intent or correct result. How? Attacker can do cause in learning system target outcome designed by the attacker. How it is possible? Attacker can try to make model will learn, training time model can learn wrongly. Testing time attacker can include some information, model can give wrong result. So learn sensitive information about possible by attacker, and that's why need security in learning system. While machine is learning, while machine is doing, we have to be careful. The attacker should not use attack. Similarly, misuse AI to attack other systems, find the vulnerability of other system, because I have huge data I got from one system, which I have looked into it. I have the huge data set. I will do some kind of machine learning and try to find some options, the vulnerability in the systems, and try to target the attacks and devise the attack. So need security in whatever system we develop. So learning time is also we require security. Protecting the security system necessary, that misuse AI is not possible. For example, adversarial machine learning is a standard one taken from the net. The Panda with 57.7% confidence, adding some error, it can be given by the machine learning techniques. Vouching for adversarial machine learning, those who are thinking that machine learning techniques is very, very good. Please remember, adversarial machine learning techniques is one of the things which can do havoc. Use of machine learning techniques in information security. So basically, learning the presence of adversary, that is one of the requirement. Adversarial example tools, learning system, attacker poison training data set to fool, selectively show learner data points to fool the system to wrong model. This is one of the important requirement to remember. So data poisoning is particularly challenging with crowdsourcing and insider attack. So my emphasis from beginning is the data. Data should not be poison, and data should not be someone insider to create problem that machine. Difficult to detect once model has poisons. So adversarial machine learning particularly important for security critical systems. If one system administrator working in system, please avoid adversarial machine learning system 2-year secure administrations. Why? Because the adversarial machine learning can do havoc unless you know loopholes of your machine learning techniques. So your machine learning techniques should be robust enough to take care of adversarial machine learning. There are two part of the cyber space, cyber crime and prevention. This is standard. I don't want to put too much mind here. The red and blue AI. Red AI is basically attacker. They do the cyber crime, and blue AI, those who are try to detect one and make a defense. So always if anyone wants to do research, you should, and you want to check your system is very good or very bad, you should have two teams. One is the red team, another is the blue team, and fight each other so that the system can be as robust as possible. So red AI people try to create malware from using machine learning, try to create smart botnet, so not easy to detect, advanced spear phishing techniques, counter threat intelligence. If they know that how threat intelligence available, they can go through the other way around to avoid the threat intelligence, unauthorized access, poisoning ML engine, what already I have told, using AI to classify victim and optimize. So basically, misuse of AI, class who from where will get maximum benefit, credentials and other things, optimize return on investment by the Red AI team and condition-based cyber attack. So basically, they look into this and make sure that things are possible. You go to the blue AI, malware detections, anti-spam, intrusion detection prevention, vulnerability management, user and entity behavior analysis. If some abnormality is found, immediately can be detected. Data classifications, cyber threat intelligence. So it's basically chicken egg problem or Tom Jerry race. So blue AI and red AI, they're fighting each other. Attacker is trying to go inside it, and protections are done by the deploy. And a new generation honeypot. This is a very, very latest topic. If you honeypot, they easily can make out today's honeypot easily detectable by attacker, and they try to bypass. And today's attacks, today's malware easily identify the sandbox and try to not to run on those sandbox. So creating one environment, this next new generation is basically creating one environment which can which can specifically is one virtualize or create one environment which appears to be a real organization, which is actually virtual organization, having web site, email, whatever in one organization can have similar type. A new generation honeypot is actually creating one environment which appears to be genuine, so that attacker or the malware can be and it trapped, and we can utilize the future detections and others. Present honeypots are easily bypassable. So basically, few areas of ML in cybersecurity identify anomalies, which is mostly we people are using. Check suspicious or unusual behavior profile, creating a profile of systems and deviation of the profile of the system. We can utilize this. Detect and correct known vulnerability. So we can scan and we find it. Suspicious behavior and zero-day attack. So possible. Over and above resource optimization, which usually we people avoid. Resource optimization is one of the important how resource can be utilized. So the accuracy and effectiveness of an attack. So if you look into this in malware detection, we are using ML. A lot of research is going on. Intrusion detection is using ML, machine learning techniques. Fraud detection and prevention, it is also used. So credit scoring is also used. Wrong, if someone is doing it, can be find it. Phishing prevention, spam filtering, botnet detections is possible in this. Cyber rating for one organization, if organization is secure and they want to make it that how secure it is, one kind of technique is called cyber rating, incident forecasting, and user authentication. All these area we can use it. I have not clearly mentioned anything related to social media analytics. They are inside it. This is known to all of you. I have just keep it because time is one of the factors. So AI/ML in finance, obviously we can use the fraud detections, identity access management, monitoring and prevention threat, insider threats, anti-money laundering, risk management, which is very, very important for one organizations. Here is why I want to put little more emphasis on risk management. As you know, we cannot come up a system with foolproof. Why? A system definitely written by the program, program written by the human being. And while writing the program, if we follow the source code, secure source coding and secure everything, plus configuration, everything we do, whatever method we do, there can unknowingly maybe there can be some vulnerability unknowingly there. Sometimes knowingly we keep those bugs. Why? Because we look into that, how much risk if I keep that, otherwise performance can go down. If I take care of each and everything, my whole process will go down. For example, I want to give this. If you look into the India today, if you go to the ATM card, if you put in the machine or internet, specifically in internet, if you are doing very small transactions, less than 2000 or 5000, specifically 2000, if you give only the PIN, the expiry date or other things, they may not check, they process immediately. Why? Because if you go through all checking each and every items, it will take long time. Instead, as it is less than 2000, why not process immediately? Contactless card, if you touch any POS, point of sales, 2000 rupees, nowhere nothing checked. So some level of risk they are taking. So while developing a system, some level of risk we'll accept, some level of risk we don't want to continue, remain there. Risk management is one of the important issue from the consultant who does the consultant related to security improvement in the system. Customer protections, regulatory compliance, these are trade in healthcare is one of these are all each and every is a big research topic. Specifically, the black market for electronic health record. This is one of the important points. You remember that our health record, whatever is available, is sold by the sale. Why? The drugs producers or those, they wanted to know what kind of health in India, health issues are India. Accordingly, they want to do all these things. The health record is one of the important. Today's scenario, IoT, IoT, Internet of Medical Things. These are all medical devices, ICU medical devices, are connected, and they are all vulnerable. They are prone to different kind of attacks, which is very, very important area of research. Unsecure will say these, all these you can see from my slides will be available in the subsequently. I want to cover up very quick. Today's scenario, the connected vehicle is another important issue. The attack on connected vehicle or IoT devices, this within the vehicle can have accident or purposefully vehicle power will, sorry, petrol will go consume more or something. Over the year updates related issue, sometime in engine main functions, we have to update the softwares. Engine control unit, if we can do something, then engine malfunctions, we can deny the working of that machine. Remote hijacking or vehicle theft, it is also possible. Denial of service, and all these things are possible in vehicular network also. So one of the important things which customary we put it here, the ethics in AI, the automation and the resulting loss of human jobs. This is one of the important things. Predictive cybersecurity, algorithmic transparency. We are supposed to have algorithmic transparency, but we don't do. While doing so, poor quality or inadequate quantity of data on which prediction is based, already I have mentioned. So we should not do such things. We should not make that job will lose. We have to create in such a way our social dynamic should not change. So we have to remember while doing such thing, we should not forget that AI should not create problem to the individuals or organizations. So we need GDP, that is privacy related things. So other things, the privacy, confidentiality, the compliance and regulatory challenges, accountability, liability, governance, bias, discrimination, all these things are very important. So some of the research area, AI for security, enhancing task hostiness of the system. What it mean? I create one system based on something, and we have to prove what is the confidence level that system is people will use it. Similarly, resilience and autonomous cyber actions. So here I want to say, if you go to the Cloudflare and if you try to attack one of the Cloudflare control protected machine by DDoS or anything, the Cloudflare have a very nice algorithm. This automated autonomous cyber actions, they have resilient and these. They look into the source of the attack by their AI systems. Once they identify source of attack or IP or organization IP, one of the machine will, Cloudflare machine will go down, taking all attacks, and the other machines of the Cloudflare will do the counter attack to the organization IPs or the host, so that the who has done the attack, they will be down for certain hours. Or will try. Basically, some actions, cyber actions, is very, very important. One example I have given: attacker-oriented cyber defense. Similarly, predictive analytical security. Security AI and of AI is another important importance. Specification and validation of AI systems. Already I have mentioned in the emphasis I have given. Task of the AI decision making. What I mentioned, adversarial machine learning or similar machine learning techniques which can spoof the AI, that has to be looked into, and we have to make task of the AI, task of the machine learning, engineering task of the AI/ML augmented systems. So this is one of the important systems. So I have to, I have very less time now. So I will give my slides, so you can use it. I am just going Blue AI related things. So AI algorithm in cyber security application, it's taken from the net. You will find each and every area AI are used. One important thing is, which is explained. Please read yourself because time is very short. I am just giving in brief. Black box AI, what is presently used is that read the data, try to find, it can be image or it can be, and try to find whatever you need and give some result without any explanation what is the things that happen. So explainable AI is one of the important things, again driven by DARPA, the USA government, that whatever decision the AI is given, decision has been taken, so that the wrong or biasness or this wrong accident or wrong biasness, everything can be clear, because the decision is given based on this. Now it's up to you or up to the system to use. Namaskar crashes because wrong recognized. AI medical diagnosis system misclassifies pattern as a disease. If you give only image and it partition it's a cancer, but it may not be a cancer. So basically, if we have explanation with the each result given by the AI, it will be good. So this is basically coming in future, that interpretable ML. So data, you have a model and you interpret the model and feedback this and continue this process. That means one human or expert or the knowledgeable persons who can analyze the data is available to rectify the result, and finally the generalization error, human experience together makes that error be minimum, or if any result is given, along with the result some explanation will be given, so that things will be very easy. I am reaching almost at the end. So motivation is two mega trends impact in cyber security: growth of malware or attacks or these things is one side, growth of devices because machine to machine communication, internet of things, medical things. So way it is increasing, keeping them in cyber secure, or they cannot misuse. That's the big challenge. So this three cyber security problem, we can look into it. Today, what we are doing, most of the researchers are doing power malware detect and prevent zero-day and polymorphic malware across multiple threats, vectors, and platforms, where we are using machine learning. We are using machine learning for this stream analysis, because our data is time series, data is stream, data cannot be used for longer. So leveraging power of machine learning, identify analysis activity, system lock, network security, social media analytics, social media data, the streaming data, and trade intelligence, leveraging power of machine learning and to prioritize, alert, provide automated trade research. This 5 days, we'll talk mainly this part, the threat intelligence related to NLP issues and streaming of data. So at the last, if you look, research methodology, this is a research circle. A circle will continue, never-ending process. We have to do that cyber threat analysis. You use, then you model security problem and try to implement it. Then collect data, then representation learning application, then machine learning customization, cyber threat analysis. Everywhere we can use AI, and every time we have to continue. It's a never-ending process. So with this, I end this my talk. We uh, we go back to the discussions. Let me see what is the things you people have given. Let me see. Uh, any questions created by anything? I am not able to see.
Yeah, sir, there are some questions.
Tell me. I am not able to see. Where is the chat? I
Okay,
am
so
able to see the chat. Okay, let me see. Go to the chat. And when I reach here, all participants. Okay, all is not the correct. So
I have noted few of the questions from
tell me.
the
Okay,
friends.
okay.
So one of the question is how to apply honeypots.
How to apply honeypots? Okay, it's a big thing. Big thing. We cannot easily apply the honeypot immediately anywhere. Honeypot related things, I will better give a link to CDAC Mohali, which specialized our ISEA program as well as G-Security Division of the MeitY. They are doing the honeypot related activity. Those who are interested, please contact CDAC Mohali. They will easily come to you, and if you agree, they can put honeypots in your place also. So it is require one simple machines and network connections and the software available in the net, or you can take from the CDAC Mohali to install it. Okay.
Okay. So another question is what are the differences between DOS and the DDoS?
Oh, okay. Then it is maybe till now not came across this issue. Denial of service is making that one uh, target or one application or it's not available or things are not available. It's called denial of service by some means. It can be machine learning means, it can be non-machine learning means, it can be just removing network connections or anything. But uh, but DDoS is basically not, and DOS is actually one attacker or one set of actions can make DOS. Whereas DDoS usually is the set of distributed actions created by a group of machines. That group of machine can be controlled by some other bot or something, so that distributed way attacking a victim. So that's why it's called distributed denial of service. Anything else?
Yeah, so there are more questions. I think we can still have some few more minutes.
A few
So,
more minutes, then you will take over. Okay.
so next question is how to use machine learning techniques for sports or game analytics.
Okay, sports or game analytics. So it is a big thing again. See, machine learning techniques is used to, I think, Dream 11, you have looked, some people have done that. ICC has already, BCCI already taken the Dream 11 as the sponsor for IPL. I think this is the latest news. If you go to the Dream 11, uh, find out they have done very nice analysis of the football or cricket match. You say that football match, those football match, they analysis Ronaldo, all these things, how they did it, what are the things, how they tackle it, what are the things. They try to mimic their things using machine learning techniques and make a game so that we can play. So basically, obviously, there are two ways we can do it. If we have video of whole match, we can analyze based on video and image analysis, and we can predict the some moves of the what is called Ronaldo or Cristiano Ronaldo or Messi, or these moves are happening. Then betting techniques can come up, or lot of things can come up using image video analytics or image analytics. If things are available in text or the audio, that broadcasting, everywhere we can analyze and we can get some conclusions, what happened, when, where, all things can be used. And obviously different machine learning technique can be used there. More than this,
Sir, I just want to supplement on this question. Dr. Saradhi, who will be taking session at 3:40, he had done lots of works on commentary analysis, basically on the cricket, for finding weakness and the strength of players and so on. So I could not track who is the person who asking this question, but you can please reiterate these questions to him, and also I'll try to remind him for these questions, and more insight on commentary analysis from that can also be looked at.
possible.
So there are some more questions, sir. Should you take up?
One maximum, one or two maximum, because we are running short of time.
Just one question, just come in. How is it different from conventional information security to machine learning information security? Please elaborate with workflow and or process, so that
it is Suresh Raja. Suresh Raja has written, and how it differ from conventional machine information security to machine learning. Conventional information security is, I think, it's very difficult to say at this moment in a generic way. As I mentioned at the beginning of my talk, that everything is domain dependent. Everything is domain decides which things can be used where. Conventional machine information security usually statistical or some standard techniques like finite state automation, or can think of hidden Markov model, or you can think of Markovian process. All these things are standard, and those standard things which takes data and model accurately and try to based on these things and finally give the result, which or anything may not predict. And obviously, huge data cannot be processed. So automatically, the huge data and modeling and those things are very, very difficult at present scenario, considering the data availability. So machine learning techniques, we'll discuss this series of actions. So subsequent lecture, Ranbir will talk about machine learning techniques. Once machine learning techniques will be learned, then automatically how to use in security will definitely will be come up. So it is pending for Ranbir to take care of while machine learning techniques. Ranbir?
Sir, yeah, just one last important question from to Shukla. The question is, what is social media tracking, and what kind of AI technology is used in social media tracking services? So I just want to supplement this to Shukla, that these courses will be on very fundamental applications of machine learning, but particularly to this question, maybe in our lab, we have built various tools. Maybe in the next session, I will just, in some of the session, following session, we'll try to give some input on this.
Correct. This is our one of the major activity of our OSINT lab, open source intelligent lab group. We have OSINT lab. We do such activity. We will bring into the forum in these 5 days in certain way. Okay. Okay.
Yeah,
we can conclude now so that you can take care of it next.
Yes, sir. With this, thank you very much for giving in like various directions of say machine learning applications. I think you have covered almost every aspects of say machine learning application in security domain. And sir, it was very interesting and insightful presentation. Thank you very much. So
Thank you.
Thank you, sir.
So with some break, how much break, Ranbir?
So maybe sir,
Or
we'll
we'll
take
start now?
about 2-3 minutes, I guess. So there are some queries from the participants. So I think we need to probably get
What
it
is the
from
question?
Naresh. So
What is the
one
query?
of the query is that how are we taking attendance? How to give attendance? This is one.
Attendance is basically it is recorded. Everything is recorded. Whoever joining or leaving is all recorded.
Okay.
In our
And
recording, because we are recording everything.
another is if there is YouTube link, and then can we share that? If there is a YouTube streaming link, can we share that? I think Naresh probably can.
Naresh easily can make it. Naresh, can you inform if you are there?
Yes, sir. Please visit infosec-awareness.in website. So YouTube, you can live watch this session, and our channel also you can also find in our channel, and we're also sharing the YouTube.
You, Naresh, you give in the chat box the
Yes.
links, whatever is possible.
Yes, sir. Yes.
Yeah. So another major query is about the resources. So can we share the resource of these presentations and this recording for future references? So
It is okay.
So that is, I think we are.
Naresh, we are giving these options because we are keeping, correct, Naresh?
Yes, sir. Yes, sir. We are keeping.
We are keeping everything. You will go through, and it is always will be available in the this website as well as
The YouTube channel.
YouTube channels.
Yes.
So no problem. We have no restrictions, nothing. Okay.
I think that was one of the major query. So yeah, I think that probably clarified this. And so before I start, so I think many of the participants wanted to ask question verbally. So is it
will
possible?
be difficult. Verbally, Naresh,
Sir.
can you
Yes,
hear
sir.
me?
Yes, sir.
At the end of the talk, Ranbir sir, if someone raise some flag, any flagging option is available?
Yes, sir. Hand raising is available.
Hand raising is available. Naresh will be there to speak. Correct?
No, sir. We cannot enable the speaking.
Oh, you cannot enable.
Yes, sir. Only chat.
No, no,
Q&A.
only chatting.
Yeah,
Okay. For the time being,
Okay.
Ranveer, because the number is very big, we cannot have a voice option. The voice option can be, we can provide our, if require OSIN lab, we can provide some channel for future discussion. Correct?
Okay. Yeah, then I think we'll manage.
We'll go through the OSIN group, some channel we will create for discussion.
So I think this is one limitation at present, asking say verbal questions. So participants, please do not disappoint. If you have any query, either you can ask in chat, and even if some of the questions are not answered in the session, we'll try to dig out and answer, try to communicate back that in some other modes.
I am putting in the other. I am putting in that we will go through the chat. Important if I missed it, and we will discuss in subsequent in between whenever we get a chance. And we will give also our OSIN lab. We will create one channel for communications.
Okay.
Fine.
That makes sense. So, thank you very much for your nice presentation.
Thank you everyone for listening me. I am signing off. I will be there, but now I hand over things to Ranbir. He is person of this. He will continue this activity, and he is also main person in our OSIN lab, open source intelligence question. I am also there, and some. So handed over to Ranbir. You start.
Yeah, thank you, sir. So I need to share this one, right? I am sharing screen. That may be.
Okay.
Can you see my screen?
Yes, we can see.
I think, So yeah, so the topic that I am going to talk about is a kind of brief introduction to machine learning. So to present this in a very non-technical manner, so that considering the vast, say, variation in the participants, so I am thinking that, like, say, a person who who are not aware of what is machine learning. So I'm just trying to give a brief, trying to give an idea what do you mean by machine learning and how to build machine learning models and so on. So that will be the primary focus of these sessions. And from tomorrow onwards, we are going to have lab sessions. In the lab sessions, we are discuss implementations of various machine learning methods and applications, their applications on, say, various applications. So here this session is going to be a kind of non-technical understanding presentation of machine learning. So just before going further, as Sir just mentioned, I just wanted to briefly introduce what what we are doing in the lab. So specifically to one of the question that how do we track social media say data. So this is one of the tool that we are building in our lab that is called Bislesaki. So what we do is like we monitor Twitter and try to perform various analysis. So this has two types of user account. One is the public domain, and another is the authenticated user. So in the public domain, only limited features are available. So what you can see now is the say publicly accessible features. So you can see that we are figuring out what are the trending hashtags presently going on. And so the rolling hashtag that you have here, these are the kind of currently trending hashtags. And the plot below is the kind of 10-second distributions, a frequency of the tweets, particular hashtags, like the first step to SSR justice. So in the last maybe about half an hour, this is the kind of traffic that we have. Like say we can do different who worship cure say disease and so on. This is again the traffic in the last about half an hour. Okay, so likewise, in addition to this, we can perform sentiment analysis, then analysis of mention, location monitoring, various activities, and so on. Okay, so this is a kind of monitoring and a tracking of various social media events. Okay, for that we have built lots of technologies for this, and we will try to highlight some of the technologies inside in one of the sessions in the later sessions. So with this, I am coming back to my presentations. So as this is very non-technical understanding explanation of what is machine learning. So so what is machine learning? So we try.
Ranveer, go to full screen mode.
Okay, sure. The screen.
Slideshow. Go to slideshow.
Is it fine?
Fine.
So what is machine learning? So in order to understand what is machine learning, so we often try to explain that, okay, machine learning is nothing but we are trying to make a machine behave like a human, right? So what do we mean by behaving like a human? So we know that human can learn from a new environment and can also make some decision their own. Like say that is what the something if we do not know also if given environment I can learn, human can learn and make decisions, right? So that is human. But if we talk about machine cannot learn. What machine does is machine can follow instruction. They only perform what has been instructed to them. So that is the difference between human and a machine. And what is the machine learning? So idea here is, can we make machine who generally perform some instruction, okay, follow some instruction, can they also start taking some decision? Can they learn from the environment and make some decision? So that is what we try to understand in the machine learning. Can a machine learn? Okay, that is what. So to understand this, let us start how human started learning from environment. So let us. So this is one typical example I used to give. Say similar kind of lectures. So the question is like when we see some vehicle on the road, can we easily identify them, whether this is a car or this is a bike, right? We can easily identify them, right? So why are we able to identify different types of vehicles on the road? It is because we have observed, have seen this object, many of these objects before with the appropriate class levels. Like say this object is a car, this object is a box, this object is a bus. Something like along with the level, we have seen many of these objects in the past. So this observation, from this observation, we started learning, we started understanding the pattern of these objects. And when we see similar object later on, we can easily say, okay, this is a car or this is a bike and so on. Right? That is why we are able to identify the say objects. But the same question, if I ask to a person, this is a very rude examples. Let us imagine that we have Tarzan who is living in jungle and who have never seen vehicles in his lifetime, right? So if I ask, what is this object? definitely he will not be able to say object, right? Because he has not learned, he has not observed this one. This, right? So, but he is a human. He can he has the ability to learn. Okay, but when he have any experience or observations, earlier observation, he do not know what is this object. But since he's a human, and if I keep on introducing him like something like this is an object called car. Likewise, many of these instances I to him, introduce to him. Then after certain iteration, so I ask what is this object. Now he will be able to identify what is this car, what is this object, right? So this process of introducing uh, these different observations to him, it is a learning phase. It is what we call as the learning. Right? Once this is learned, means understand. Okay, car means it has four wheels, kind of curvy shape, and so on. Then once he knows that, so he will say next time he will be able to, when next time he see the similar object, he will be able to say what is the object. So this is what the learning, what we mean by learning. So when we talk about human learning, so just from previous example, what we have seen is that we learn from observations, we learn from experience. So what do I mean by experience? Is nothing but observations of those objects again and again, right? That is what the experience. Here. So now we have seen that a human can learn from experience, machine follows, and machine learning is nothing but learn from the data. So we want to make machine behave like a human. Okay, that is machine learning. That is nothing but we are going to supply lots of data to the machines, and that machines is we are going to treat as an observations. From this data, machine is going to learn. So machine learning is nothing but learning from the data. Define this machine learning formally. Okay? So there has been very definitions, but one of the well-accepted definitions of machine learning you can find from a learning book by Tom Mitchell. It defines that a computer program is set to learn from. So you should mark experience E, okay, with respect to class of tasks T. That means you should have some underlying tasks to perform, and you should have experience is nothing but those observations. Okay, and after performing those tasks, you should have to measure the performance. So you have three things here: E, T, and the P. E is the experience, that is nothing but observations that you have, and task to be performed. And when you perform, you should be able to measure the performance. That is, are you able to perform successfully or not? Okay. So you should have these three abilities. And the underlying observation is that learning is that if performance at task T as measured by P improve with experience, that means have more amount of experiences, the performance P should be improved. Okay, that means learning is nothing but improving with experience at some task. So this is the kind of well accepted definition for say to improve over a task T with respect to performance P based on some. Okay, so this is the machine learning definition. So, just to take examples, vehicle in a parking lot is the say task, and the percentage of verification is the performance, and know how to from previous successful and the fail identification. These are the experience. let us see how to build a machine learning model and how a machine can learn. So in this, what I'm trying to explain is, given the set of observations, given the set of objects, how do we actually identify objects? Okay. So with this example, I'm trying to explain what do you mean by building a machine learning model. Okay. So the type of object that I have considered is vehicles, one car and a bike, and the task is something like you are giving this a set of car and a set of bike to the say machine. The job is to identify whether a particular vehicle is a car or bike. Okay. So how do you perform this task? Okay, how do you build a machine learning model to perform this task? Okay. So this is what I'm saying. So before going further, let us just try to visualize that this machine is nothing but myself. I am standing in the parking lot. Okay, then so then whenever our vehicle comes, my task is to say is a car or bike. Okay, let us assume that I say I have probably closed my eyes, and there are some sensors. So when I'm not looking at the vehicle, I'm closing my eyes, and I have sensors. What this sensor does is this sensor will tell me how many wheels this object is having, what is the weight of object, what is the height of this object, what is the color of object, and so on. Okay. Now, given this set of sensors, okay, I'm closing my eyes, and when a vehicle comes, this sensor tells me that okay, this object is having 4 wheels, right? So the moment I know that there is a this object having 4 wheels, then without any problem, I can say that even if I close my eyes, I can say that this object is a car, right? Similarly, like say so, and if we say that this object incoming object is having 2 wheels, I can say that this object is a bike. Okay. So now, so what is this 4 and what is this 2? So in any machine learning model, okay, one of the most important steps is to represent this object in a form that is understood by my computer or my program. Okay, because my program cannot directly take this object car and cannot take this bike as input, right? So in order to able to process the object, so the object vehicle should be represented in some forms, and that form should be able to so that this say my program can understand and process the forms. Okay, this is the representation. So depending on the nature of the underlying problem, first task is the samples should be represented in certain form which is understood by the program. Okay. One of the well accepted form is called vector space model. That means every object will be represented by a vector. Okay. So the moment we represent a object by a vector, that means the vector will have certain elements, right? And each of these elements will correspond to certain features. So when you say that the car is having, say, just by knowing the, say, how many number of wheels this object is having, okay, I can easily identify what is the type of object, even if I do not see the objects, right? Without looking at the vehicle, if I know that how many wheels are there, I can easily say what is the type of this vehicle. Okay, so this wheels is one such feature. Okay, likewise, what is the color of this object? Maybe color black, red, blue, and so on. This is also another features that used to represent this object. Likewise, what is the height of this object? Is it the 5 feet or 4 feet or say 2 feet and so on? This is also another features that can be considered, right? Likewise, weight of the object, is it some 500 kilo or kilo and so on? That is also likewise given an object. So very first task of any machine learning is depending on the underlying problem. Given sample or given object should be represented in some forms understood by the programs. So in many machine learning techniques, well accepted form is called vector space model. That means every object will be represented by a vector. So the moment you say vector, how many elements you will be considering in your vector, right? That is the number of features. So if I say that I will be using only the numbers to represent my objects, then vehicles, then I will say considering only one features. If I say I will be considering the number of wheels, height of the vehicles as the features, then I am considering two features. Then I may also consider weight and so on. The number of that you will be considering to represent the object should be defined. Okay, this is the feature engineering steps. First, you need to find out what are the appropriate features that can be used to represent represent the samples. Okay, so this is the first step in any machine learning models representation. Okay, and the type of representation is vector space model. That means every samples will be defined, and the size of the vector is nothing but the set of features that you have identified or set of features that you have considered. Okay. So the moment you say features, then there is a question of features and bad features. Good features means, so let us see what do I mean by good features, right? So I am closing my eyes and the sensor is telling that the vehicle is having 4 wheels, then immediately I'm say what is the type of the vehicle. Like 4 wheels means it is a car, right? So this is a good features. But instead of the number of wheels, if the sensor is telling that, okay, the color of the vehicle is red, then what is the type of vehicle only from the color? It's very right. Car also, bike also may have red color. So color is not a good feature. Likewise, say if someone sensor says that the weight of the vehicle is something 500 kilo, then most likely it may be car because bike will be light. Then this is also a good feature. So likewise, it is very important to identify good features. Okay, in the machine learning model, performance of any machine learning model will depend on the quality of the features. If you are able to find a good features, then your model will be well. If you are not able to find good features, then you will not be able to say your model will not be performing well. So feature identification, feature engineering is one of the core in machine learning. So that is what I wanted to say. So first step is representing the objects. So your data might be text. If you have something like if you want to do some text classification, so when you have text, what are the features? How every document will be represented? If you have an image, how do you represent image, right? If you have graph, how do you represent graph? So this representation has to be fixed. So irrespective of is it image or it is a graph or is it text, if your underlying network model is accepting the vector space model representation, this sample should be transformed into the representation understood by your learning models, okay, your say machine learning methods. So this feature identification and the representation is one of the most important step in any machine models. So with this understanding, let us see what do I mean by say machine learning methods. Okay, so example, I am considering this set of tasks. So now my task is performed. So let us say I already have this machine. I already have this number of samples, the 3 cars and the 3 bikes. And these vehicles are represented by wheels. So that means only by wheels, only features, 4, 4, 4, 2, 2, 2, and so on. This is what you is given to my program. Okay. After that, now I got a new vehicles coming into the parking lot, and the sensor says it is having 4 wheels and what is the type of vehicle. So this is the underlying task. Okay. This task is called classification task that I will explain later on. But for a time being, without knowing what is the nature of the problem, let us say this is what the task in my hand. So I have this set of examples that I already have. And from these examples, I know that car means 4 wheels, by 2 wheels. Okay, then a new vehicle comes with the 4 wheels. I'm asking what is the class levels. So this is called class, but that is later. So having this, so what I mean by building a learning model. Okay. So from these data sets, I can easily find some probability. If I have 4 number of wheels, what probability of being car? Okay. From this data set, if you see all the vehicles with 4 wheels are car, that is 100%, right? All the vehicles with 2 wheels are bike with 100%. So finding probability is nothing but building my classifier. Okay. The moment I from my data set, the moment I have this probability estimates, okay, then I can easily. So if I have 4 wheels, what is the probability of being car? That is 100%. If I have 4 wheels, what is the probability of being bike? 0%, right? If you have 4 wheels, probability of being car is 100%. That means if you have 4 wheels, probability of being car bike is 0%. So see a vehicle with 4, so I can from this probability estimates I can directly say this is car. So estimate probability. Okay, this is also one form of learning one form of learning. Okay, like say a car is having 4 wheels. So this is the framework. So when I okay, in one type of machine learning, quite often you are going to deal with something, say something called training data. That the observation that I was explaining, right? Training data and historical data and observation data, they are all same. So I have something called training data. So from training data, I'm going to calculate this probability. The moment calculate this probability for any new examples, I can estimate the probability of being car given the number of wheels, right? Like this. So from this training data, estimating this probability is nothing but building a classifier. Okay, building a machine learning model. So do I? Okay, I am not able. Okay, so this is what say building say learning models from say training data. Okay, training data is nothing but the collection of samples from which you are trying to estimate those model parameters that will help you in taking the decisions. Okay. So this classification process I can visualize in as well. Okay, so one way of visualizing was something like say estimating the probability. Another simple way of visualizing this can be, let us say these wheels features, I have plotted them in a, because I have only one features, I have plotted in a one-dimensional space. So like say this x-axis, the number of wheels. So I have 1, 2, 3, 4, 5. And so now, if you plot these samples in this say linear space, what happen? All the cars are having 4 wheels will lie somewhere here, right? All the bikes will be having in 2 wheels, so they will be lying somewhere here, right? From the moment I plot these samples into this linear space, I see that all the bikes are say in the left side, and all the cars are in the right hand side, and the bikes are say less than 3, and cars are having more than say 3. So then this also I can probably form a rule, something like if wheels is less than 3, then it is a bike, else it is a car. That way also I can build my classifier. Okay, so this is also plotting all these samples in this linear space, and I'm trying to find this separate that is nothing but 3. Less than 3 is bike, more than 3 is car. This is also building another classifier. So what I'm trying to say, you may have various forms of classification models for achieving the same objective. So here I'm showing one classification models from the probability estimates, another classification models from plots, like these rules. If wheels is less than 3, bike is car. So this is building a classifier, building a linear learning models. So what is machine learning now? What is building a classifier now? So classifier or building a classifier is nothing but trying to understand those characteristics of the features that will discriminate one class from. So I want to find some separating rules, right? What is that rules? So from the set of features, like say wheels, I want to find that will say this is car, this is bike. Okay. So understand those characteristics that will discriminate from one class to another from data. Okay, that is what the building a classifier. So classification, any classification, our underlying goal is to find these different discriminating characteristics. You may have various solutions, but for achieving the same goal, that is what the say building a classifier. So from which data set you are learning those characteristics, discriminating characteristics, that is from your training data. Okay, so that is what the training data. So just to elaborate this example little, let us add some noise. Okay, so now I am considering only wheels, and let us now, you can also see that there are some bikes with 4 wheels. And so I'm adding some noise here. So there are some differently able people having 4 wheels and so on. So a bike will be say 4 wheels. So in the, if I try to estimate probability, you can see that for the if it is 2 wheels with 100% it is bike, but if it is 4 wheels with 60% it is car, and with 40% it is bike, right? So in this scenario, if I have an example, you have 4 wheels and what is the vehicle types. Then since car is having 60% and when you have 4 wheels, I probably will say this is car. There is a probability of error. There is a chances of having error. The chances of having 40% error. My decision may go wrong with 40%. Say because some of the bikes are also having say 4 wheels. Right? Then my problem is not as simple as earlier problem. So how do you resolve this problem? Then only solution that I can have is let us look for more number of features. Say now instead of considering only wheels, let us increase the also include heights, more number of say features, right? So when I introduce another features, so now you can see that everything is 100%. So the notion that I'm trying to give here is, so the features feature selection is very important. Identifying features is very important. So with limited number of features, you may not be able to differentiate classes, but when you have number of features, you may be able to differentiate. Okay. So rule is like more the features, better is the performance. Provided your features are good. So depending on the underlying problem, we may for more features, okay, to achieve this kind of higher performance. Okay. So the moment I include heights, then everything is 100%. So when I project in it two features, that means 2 dimension. I have wheels in the x-axis and the height in the y-axis. Then I plot them. This example, I can see that all the cars are having 4 wheels and it is in the higher side. All the bikes are in the lower side. So I have a separating rules. So this line can separate car from the bikes, right? So adding more feature is. So once I have this, so building a classifier, I think from these training examples, this separating line, or let us get some rules. If this is equal to 4, this is say equal to 4, this is bike. If it is equal to 4, then height is high, then it is car, otherwise car. Some rules also I can find. Okay. So I can have various forms of classifiers, okay, depending on the this is what the classification. Okay. So I'm just trying to give a very layman understanding of what do you mean by machine learning, and what do you mean by building a machine learning model or building a classification model. So just to summarize what we just discussed, okay. First step, what I mentioned was depending on the underlying problem, should be appropriately represented by identifying appropriate features. So feature identification is one of the most important component. If you do not have good features, no matter how good is your classification model, your performance will not be good. So good features. Second is once you have the features, present the samples. So in this example, we have used vector to represent the sample. Okay. Then once I have represent this, once I identify the features, happen that say you have many features, especially in the text domain, the number of features are quite often in terms of 1,000, 100,000, millions, and so on. Okay. The number of features is quite large. So when large number of features, there are 2 issues. One is that many of these not be good features. Then you have to throw away those unuseful features. Those features which are not useful, you have to throw away. That means you have to identify good features from the features that you have considered. That is called feature selection. Learning, when you study, if you have something like feature selection, so feature selection basically means you are trying to ignore some of the features. Like say the vehicle example, color is not a good features, even if it is a potential features, but it is not a good features, right? I am ignoring color. I am only selecting something like wheels, height, weight, and so on. This is called feature selection. Feature selection means identify good features and select. Another is called dimension reduction. Okay. Feature selection also try to reduce the number of features, less number of features, by throwing some of the features. That means you are losing some information. Okay. Dimension reduction is different. So quite often students confuse between reduction and the dimension reduction. Dimension reduction is not throwing the feature away. Dimension reduction is you are keeping all the features and the projecting to lower dimension. Let's say your original data is in 3-dimensional space. Okay. Then using some methods, you are transforming this 3-dimensional 2-dimensional space. Transformation, not removing. So I can also transform 2-dimensional space by removing jet features, right? By considering only X and Y, by throwing the jet features. So if I'm throwing the jet features, then it is a feature selection. So I'm considering X, Y, Z 3-dimensional features, and without throwing any information, I'm transforming into 2-dimensional space, some projection, using some projection mechanism to the lower dimensional space. That is called dimension reduction. Okay. So component, once you define the features and represent, next important step is called feature selection or dimension reduction to reduce the number of features. So dimension reductions helps in many so large the number of features, your computational resource will be high. Taking for learning the model will be high. So lower the dimension space, lower the dimension, faster. Okay. At the same time, it may also, when you reduce the dimension, select the features, you may also remove some of the noise present in the data. Okay. So this is another important step. So first 3 points are representing a sample properly. Okay. Once it is properly represented, then you learn the model, you build the learning models. So this is the 4 important machine learning steps I need to understand when you try to build say learning models from for a say problem domain or something. Brief introduction. I am just trying to define different machine learning paradigms. So, so in the literature, you may see machine learning paradigms like this. So one of the paradigm is called supervised learning. Okay. So one question is, what is vector space model? So vector space model means you are representing a sample by a vector. So in our example here, see, if you see the first car, I am represented by a vector 4 and ice. This is one vector. So vector space model means I am representing a vector. So the moment you say represented by a vector, I have to have the list of features. So the first element in this vector space representation, the dimension is 2. That means I have 2 features. The first element corresponds to wheels, and second element will always corresponds to height. Okay. So this is what so I just miss the, but from the screen maybe I will come back after this one. One is the supervised learning. What is supervised learning? The example that I have just taken, okay, this is called supervised learning. Supervised learning means you are trying to learn something from your historical information or training data. So if you have a training data, and from this training data, if you are going to learn some characteristics, and you are going to apply that learned characteristics on a new data, then any of such kind of problem is called supervised problem. So under the supervised problem, so I am also defining learning from experience, using some output map. Means this experience is nothing but the observed data or the training data, and this will produce some output. Okay. So this is so supervised learnings are trying to build some function producing from your training data. I also just missed the message pop-up. I will come back maybe after this. So supervised, when you say learning, please note that you will always have something called training data. From this data, I'm going to learn the characteristics, and I'm going to, my target is to produce output. Okay. If the output that you are going to produce, okay, it is a categorical output, then it is called classification. Categorical means yes, no, bike, car, okay, 0, 1, this kind of categorical output, then it is called classification. So when you define a classification task will always produce one of the output defined for that classifier. So what I mean by defined for that classifier means the output that you are trying to define, okay, it is the output that you are going to define. For this example, my outputs are something like car and a bike. If so, this output should be predefined. The class level should be predefined. Okay, and this classifier produce only producing these outputs. It cannot produce other output other than this. Okay. It should be predefined, and this should be discrete. In the case of regression problem, this is also supervised, but in the case of regression problem, your output is something like some continuous value. Okay, instead of 0, I think you are going to produce some real continuous value. Elaborate an example. Let us say you have the price of the vehicle. Let us say I have a car, something like one particular car model, and over the years you have different price on road price, and then I want to predict another 5 years what may be the price of this vehicle, right? So my previous previous historical price, like this year this is something like 5 lakhs, previous year it was 4 lakhs, previous to previous it was 2 lakhs, and this is my training data or historical data. So considering this, I want to predict what value of this car after say 2 years. I want to predict some. So this kind of, so if you are looking for a real number, then it is a regression. So classification and regression are popular machine learning methods to supervise a category. Under the unsupervised methods, so unsupervised method, in this case, we are looking for some this kind of discrete output, yes, no, or continuous values. Our task is to discover some pattern, okay, inherently present in the data. So in the unsupervised, again, two important say problems are like clustering and association. So clustering is like, say, grouping similar objects. Okay. So let us just change the problem definition. I was trying to find what is the type of the vehicle. Okay. Then let us change. Instead of trying to find a type of vehicles, if I say, okay, look, in this parking lot, there are say collection of vehicles. You try to group similar vehicles together. You look at the group the similar vehicles together. So this is a clustering problem. In a clustering problem, you try to find a group similar objects together. Okay? So for performing this, I don't need to know what is the type of this behavior, right? I just observe instantly. I just see the objects, and oh, this are similar, so I group them together. And these objects are similar, I group them together. So for doing this, I don't need to know, say, previous experience. I don't need to know the training data. Let us go back to this classic, this interesting one. So Tarzan, if I ask, instead of asking what is the vehicle, if I say, okay, look at this vehicle, group them together, right? He will be able to group them together. So these objects are similar, even if he have never seen these objects, right? This is what the clustering, group them together. Interesting is something like association rules mining. Something like when you do say purchase some item from Amazon or something, quite often you will see below, like the people who buy these books may also likely to buy this set of books and so on. So these are called association between objects. Okay? So how they do this is they record, analyze the collection of this transaction set of users and see what are the items that are bought together. Okay. So this is the association rules mining, okay. And so this is also unsupervised learning. Okay. Then there is another type called semi-supervised learning, where the problem is between supervised and unsupervised. So I think I will skip that point. So last thing is the reinforcement learning, but I think this program will not be covering reinforcement learning. But just to give a background, I'll try to explain what is reinforcement learning. So reinforcement learning is also called as learning to control, or say learning from control. Okay. So let us try to understand this with one example. Let's say you are trying to learn riding cycle. When you try to learn riding cycle, what say sometimes if you are trying to learn riding cycle from some supervised methods, then what scenario? Then scenario will be something like, okay, from your previous experience, from okay, you have to pedal, say in this manner, much pressure, and you have to handle, hold the handle in this manner, and so on. Different instances you have to define. That is what the training data. From there, you have to say now come up with the strategy how to run cycle successfully. Okay. That is how we have to do in the supervised manner. But in reinforcement learning, you have something called environment and agent. Okay. Environment is like you are the agent, riding cycle, you are the agent. Environment is like, say your friends are looking at you while you're trying to learn riding cycles. Then whenever you are successful, right, they will clap. And whenever you fall, they maybe probably they will shout you to be careful and so on. Right. So likewise, this is the feedback, say interaction between the agent and the in a closed manner. When so you will know when do you get when you people clap, it's a kind of getting rewards, like you are doing successfully. So when you fall, like giving penalty, okay, that you are so people shouting, that is like a penalty. So for every action you're going to get some kind of rewards, and that will come as a feedback to the end. Okay, and from various this trial and error approach, okay, you will learn how to do it. Okay. So that is how we do in the reinforcement learning. Okay. So this is the brief introductions of machine learning. So I think I will skip this part. So what we have discussed is I have just tried to define what are the say different paradigms of machine learning. How do you build a classifier from scratch. How do you actually learn a classification model from scratch? Okay. So different types of classifiers and different types of clustering methods we will be learning in lab sessions. Okay. So yeah. So with this, I would like to stop here. A time constraint. Maybe you have any question. How do I go to chat?
I will tell you.
Yeah, sir. No.
Training a model with noisy gives high error. How can we handle this issue? The noise in data.
Noise in data, it depends on the underlying problems. So one way of identifying noise is by doing feature selection and dimension reductions, some of the noise we can reduce. In addition to this, there is also something called, noisy samples. So noise can come from features. Noise coming from features, then we have to apply, say, something like feature engineering approaches, such as feature selection or dimension reduction or some other transformation, kernel functions, and so on. And the noise can also be from the data. So I can have sample can also be noisy. So if it is a sample is noisy, we can also do something like outlier detection and so on. Sample can be removed. So some of these methods we'll be looking at in the second day lab sessions.
Same question related to noise for regression task. Training data noise for regression task.
Yeah, regression also see in the regression model is like curve fitting. You will never have a perfectly fitting curve, right? So there will always be a certain fraction of error. Okay, so we have to agree acceptable errors, but so this error can be reduced only, I think, by doing this feature engineering and these representations.
Okay.
That few examples.
Okay. Next question is feature selection, feature engineering, dimension reduction are part of pre-processing.
Okay, so they are different from classification or learning models, but they are very much important component. So when I say classifier, when I say classifier like SVM, okay, SVM will assume that your underlying representation is kind of in the some agreed upon. Okay, so before applying the classification models, you have to do all these steps. So in one sense, you can say that this is pre-processing steps before applying the learning models, but these steps are very important steps.
Next, it is talking about that it is clear that before the training we have to do this, but if we do not get accuracy, we have to repeat this whole process to get better accuracy.
No. See, you have to really see why you are not getting good accuracy. So when you build a classifier, why are you not getting good accuracy? Because you do not have such kind of well separable strategy, or say you don't have this hyperplane, right? So you are not having well separable means what? Some of the classes are quite similar, they are quite overlapping. So until unless you resolve that, this issue will be there. So how to improve, say, this accuracy? One way is that your model is not able to capture inherently separable characteristics. that in that case, you have to improve the classification methods. Have the classification methods. If your features are not, well representing your underlying data, then you have to improve the feature representation. That is where in the deep learning models and so on, because the features that I am talking about is human identified features. Explicitly, you are identifying, like say, will. So I may be wrong, right? So the person who is identifying the feature. So in a complex scenario, it may be difficult to identify features. So that is where some of the deep learning models, they can do this. They can come up with the well representing features that will also improve the performance. So as far as accuracy performance is concerned, it may be based on several factors. But if you are able to get a good features automatically or manually, that your underlying model will always perform good.
Another thing is talking about one of participant is that other than accuracy, any performance metrics we have to see.
Yeah, we have to. Accuracy is one of the metrics. Precision recalls, F measures, and then ROC curve, and so on. So this we are discussing in the lab sessions because we have
AUC also.
score, ROC curve.
That's all. No more questions.
Then thank you very much for your presence.
Next session. Talk about next session.
So in the next session, Anand will be talking about
next session. As per record, is Saradi. Which one you are talking?
No, Saradi, he has some. Sardi and Ashish Anand, they will be swapping. So
okay.
First session will be Anand, second session will be taken by Sardi. So,
okay. So
to sports, so the second session, Dr. Sardi, okay, you can also put.
So we'll start at 2:30 dot.
2:30, sir.
Dot. No change. What if all of please join 2:25?
Yes, sir. Yes.
Okay.
So in the same link, through same link. Please join through
Same.
same link.
Please join by 2:25. We'll start at 2:30. Thank you for this session, morning session. We'll see you in afternoon session. Thank you. Okay, we'll close now.
Sir. Good afternoon, everyone. Yeah, I think Ashish is able to join. Ashish,
Am I audible?
oh, yes.
Okay. Should I try to share my screen?
Yes, you can share your screen, but maybe we'll wait for 1 or 2 minutes because
Yeah,
participants are still joining. Uh-huh.
sure. I think I'm just trying to share and test if things works.
Sure.
Am I? Is my screen?
Yes. Your screen is visible, but I think you can put in the full screen.
Yeah.
Uh-huh.
Is it okay?
On my terminal, it is still not in full screen. Yeah, now it is in full screen. So, Naresh, shall we wait for some time or start the session? So, Ashish, maybe 1 minute we'll wait and start. Okay, so welcome back. Good afternoon, all the everyone, and thanks to Dr. Ashish. So, let me briefly introduce Dr. Ashish. So, Dr. Ashish is presently an associate professor in the Department of Computer Science and Engineering, IIT Guwahati. He got his master's from IIT Kanpur and PhD from NTU Singapore, and the postdoctoral from Institute of Pasteur Paris. He worked in the area of NLP, biomedical text mining, computational biology, deep learning. Uh, so he has significant number of publication in these areas. So Ashish, with this introduction, I request Ashish to please start the sessions.
Well as an opportunity to give the talk in this training program. So I am primarily the NLP, social media text analysis, how the natural language processing or what role the natural language processing has to play in social media text analysis. So this is not focusing on any particular problem, but giving you a general background to understand what is NLP and you know it's a hard problem and certain let's say that ask social media, which actually the what kind of social media text post for natural language processing, and I have kept it at a very well. Not I have not included any mathematics or anything, just to sort of make sure. I'm sort of assuming the participants are from white background to understand that what are the challenges they have to face and what are the issues they should and before diving deep into let's say that NLP and using NLP for social media text analysis. So keeping this kind of this objective in view, I have talked into the four components. First is I'm sort of trying to sort of introduce to you that what do we mean by NLP, natural language processing, and with under that components, I'm trying to make you aware that there are a lot of things which you use today in your day-to-day activity. In the background of it, it's basically NLP is sort of has a major role to play. Then to sort of give you an idea that why some of the things which look so easy or let's say that so important, but it only let's say that recent time we see that there is a substantial thing that or substantial advancements have so why that has happened. So sort of try to understand that through that why this NLP is a hard problem. And then we will sort of try to sort of see that why this processing for the social media is what specific challenges social media text pose. Can we use the natural language processing methods and the tools which are developed for regular or the formal text, can the it would be simply be used in the context of social media text? If not, then what are the different challenges and what are the things we have to keep in mind? And that is what I want to sort of emphasize during this talk, that some of these aspects want to be very, very clear, want to be that these aspects they have taken care of. Then only they can sort of go to the subsequent stage and do more analytics on these data. And briefly, maybe one or two slides that how you can start, and again re-emphasizing that what are the very basic processing steps you should focus on. Let's look into these examples that it's always easy to understand the importance of a field when you look into uses one or the other search engine, and as you start typing a few characters or a few words, immediately it's actually starts showing you that, okay, this is what I want to search for, and you can just try to choose, oh, this is what my intention. So you might just writing NLP industry, so it's already suggesting you to that. Ranveer, am I audible?
There's some distortion, but still, audible.
Yes, sir, you're audible.
Oh, thank you. Some network issue at my end. Sorry for that. Hopefully, people will understand what I'm trying to convey. Yeah. So in this example, you see that as soon as you start typing few words, it's already started showing you few of the options, and you can actually choose. So again, this is something on a very, let's say that the basic form of, you can call it the language model, which is a core of, let's say that the natural language processing, to try to understand or try to predict that what is the next word, probable next word, or what is the most probable sentence given, let's say that the few words can be. So this is sort of the one of the examples which one of us uh, every day. Many of us also required to use these machine translation, and if you observe recent years, the quality of the machine translation has improved significantly. Although still there is a lot of improvement required, but it has improved significantly. And again, for that problem also, the underlying thing, one of the underlying aspect of the is the language models hidden there. Uh, and also, another example which you see that even now this has start happening in your the mobile messengers as well. That where you receive an SMS and it also start suggesting you that what could be the short reply can be there. And Gmail also has started using it for some time ago. Uh, uh, and let's talk about some of the specific examples which we see in the context of the social media. So, for example, in Twitter, as soon as anybody face any
Ashish?
problem with particular letter, yes, yes,
Yeah, I sorry to disturb you, but on my terminal slide is not changing. So I'm just wondering, other participants, are they facing similar problem? Yeah, just now it is changed. So it changed to slide number
so
4.
slide. Uh,
So now slide number 2, it changed to slide number 4 now. But is it on slide number 4 now?
uh,
Uh, okay. So a participant, are you facing similar problem? Yeah, I think they are also facing similar problem. Uh, okay. So how are you sharing? Are you sharing a screen or a PPT?
PPT.
Oh, okay. I think while sharing PPT, I think there are some issues. Now it is in the slide number.
Next up.
Yeah, if you share a screen, I think that probably have better synchronization. So now it moves to slide number 8. I think maybe because of delay.
Uh,
stop
do I
sharing.
go back?
As stop sharing, then share screen, then done.
I think
YouTube is not coming to me.
so if you click on the share content,
Content is not coming because right now only I can see my slides
Oh.
and I can see.
You go top of your screen, you will get the menu. And stop sharing. Then share full screen.
Actually, it is not coming that way. I don't know. Let me see. Okay. Now it's coming. Stop sharing. Okay. Share content. So what do you see? Do you see anything?
on screen there is no change. Have you stopped sharing?
I have stopped sharing. Okay. I'm trying to share my screen. Share screen.
So on my screen is a kind of stuck in slide number 4. Other participant, can you see some any changes?
No, I think screen is not yet shared. Share screen.
I am able to see slide number 8.
Yeah,
Of the
yeah,
old before
old
sharing.
one. Yeah, I think
That
others.
is still being shown. But I have changed that. Not changed that.
Change is not reflecting. I don't know.
Otherwise, Ashish, one quick thing you can try, maybe if you disconnect and join again, because I also faced similar problem when my mic was having some issue.
Oh,
So
do
if
you
you
see anything now?
no chances. So if you probably leave the room and join again, I think that may probably refresh again.
Okay, okay. Um,
Ranveer,
Oh, sir.
Ashish not yet done. Ashish is continuing.
Yeah, I think he's still in the room.
I think something wrong with his side.
Yeah, I think it may be due to net connection also.
Net connections. So you have some questions at 12:02. I am grouping. Sir, you have mentioned that if wheel is less than 3, then it is by something puncture here and come back, and more number of wheels, stepney and other things there. Someone has mentioned.
So I think there are 2 sessions from Ashish.
What happened to Ashish? He is not yet joined.
It is showing 2 sessions.
Am I audible?
Ashish,
Yes.
you
Yes.
are audible.
You
Have
are
you
audible, but your screen is still at 8.
How come? Because I have disconnected and I'm now rejoined.
Oh, Ashish Anand, two instances. Hey, Naresh.
There are 2 sessions from
Naresh. Now earlier session no remain. Now it is okay. Now share.
Okay.
Now Ashish share. Now share. It is okay. Share now.
Okay. Okay.
Share screen.
Yeah, I'm. Yes,
Coming.
I think it's coming now.
Wait.
I think it is loading. Yes, we
Now?
can see screen now. Yes.
Okay.
We are.
Now
we can
change
see
the slide.
your
Change slide. Let us see. 8.
slide number 8.
8. I can see 8.
8. So I'm
Change.
you change anything?
Not yet.
Yeah, I think it may be because of network problem as well.
I sent by email to one of you and
Okay,
you
Ranveer.
can see.
You send it to Ranveer. No problem.
Yeah. You send to me. I will share screen from
I
here.
will, yeah, that would be better. I've done this before. Network is very slow at my end.
Yes. Send it to Ranveer.
No, yet to receive.
Yeah, just a second. Ranveer, ID?
No, Dropbox might be an issue. Can you? Is it possible by email? Otherwise, Google Drive. Uh, Google Drive or say Microsoft One also fine.
OneDrive should be okay.
Microsoft One should be fine.
Same issue actually, because the file is 2 MB, some time to operate. It's better networks, but due to poor weather, file is very bad.
As far as it's done,
I'm yet to.
okay, you continue to talking and doing this. Otherwise, everyone will go. Start talking and doing. Okay.
So, saying I will just speak without sharing any.
It's
Sir,
okay.
sir, if you don't mind, please send it to me, sir. I will run from here the PPT.
Full silence. Please bear with us. There is a problem in network.
I'm sorry for this. Today I will just meeting with Microsoft team. So bad. Well, bad, but it's not taking that much of a problem. Interruption, but able to some of the students are not able to hear me properly.
Yes, sir, there is a lot of disturbance in your voice. It is breaking continuously.
No, once data will go away, the voice will be okay. Rambir, have you got it?
Not yet, actually.
He gave up catching the
Who is
point.
gave up?
Gave up to try to catch the point. Ranveer, I can send you on WhatsApp. Try that.
WhatsApp also fine, no problem. If you can send me. So Ashish, you can send me over WhatsApp also, if it works.
In the meantime, you start
Yeah.
talking something.
Yeah. I will try to check with the other network also. But just give me a minute.
Okay.
Nandi sir,
Yes.
in the meantime, maybe if you can share some lights on different kind of opportunity in information security.
Okay. Okay. Okay.
Uh,
Okay. Let us talk about what are, till Ashish will come back. Let us talk something about ISEA latest activities. All of us in ISEA community and those who are participating this time, we are considering all of you in the ISEA community and specifically for future ISEA adventure or venture or joint venture or collaborative cooperative options. We ISEA we are coming up with activities ISEA phase 3, which is likely to come up in coming year sometime, and where we want participation of each and every persons who likely to do to information security in this way. So be private, be public, be a government organization, state or central, all of you can be with us in ICA Venture 3. There, our emphasis is collaborative, cooperative actions, and those who are in the participants, please find some options, some subjects, some topics, some area where collaborative effort is possible. No individual will be allowed to participate other than attending conference, presenting paper, or attending our different activities. But if you want to be part of the ISC activity, please come up with collaborative options, new area, latest topics in the, for example, social media analytics. You can collaborate with different organizations, IIT Guwahati, then some other institute and institute together can come up to bring out a good proposal where we can deliberate and we can put emphasis on a cluster. That cluster can work together and we are able to do a lot of future deliverable like proof of concepts, products. All these things are very, very important. So from self-reliant, sustainable Atmanirbhar Bharat. So if you have any questions, you can put it. I will give some answers related to. We'll have a mentorship program. We have mentee mentorship. We have a common project. We have a lot of togetherness, collaborative options will be there. If any participants want to, please
Yeah, Ashish, I
give
have
me.
got your slide.
So all participants, if you have any questions related to contributing in the future endeavor, please give your questions. I'll try to answer one by one, and we ensure that your participants in some capacity in our future adventure endeavor. Ashish, done? Ranveer?
I have received his slide, so
Yeah, I have
I'm
sent it to Ranveer.
yes, I received it. So
Ah.
I'm sharing now. I'm sharing the
Share.
screen.
Ah,
Can you see my slide screen?
yes.
So
Okay, now we got it.
I will move to slide number 8. Ashish.
Yes, yes, yes.
Okay, Ashish, can you start from one by one, just short?
Yeah, okay, fine. I can sort of restart so that people are.
Mhm. Okay. Ranveer from first slide.
Yeah, yes. Slide is gone. Yes,
So which
now
slide
it's
I
here.
should go?
Go to this second slide.
Okay.
Move forward. Move forward. So basically, again, sort of re-emphasize that this talk is divided into the four. First component which I am talking about is try to make you understand that what is NLP and some of the examples which we see every day. Yes. So one of the example is that automatic search query completion. A very core component of natural language processing, what we call is the language models, where we try to estimate probability of next word or probability of a probable sentence. So that is what actually language model does, and that is what this automatic search query completion or the prediction of the next word, which we see in our when you are trying to enter search query, when you try to type on your WhatsApp message. So all of these are actually kind of a sum of language being applied, and in core, that is a sort of an example of NLP being used. The second is, okay, Ranveer, can you please move ahead? And another one is the machine translation. So this is another example where the natural language processing is being implied. And you might have observed that this has sort of significantly improved because of several reasons. And one of the reasons is that the application of or advancement of the neural network based methods, which allows to sort of generalize under certain circumstances better so that has been sort of implied here. And again, one of the core components for the machine translation is a language model. Okay, please move ahead. Please move ahead. These examples are okay. Move ahead. The chatbots are another example of the natural language processing which is being used. And now here I wanted to emphasize. No, go back. Go move ahead. Move ahead. So no, no, Ranveer, please move back the example slide. Slide
Okay.
8. Slide 8. 8. Move. Yes, yes. So this is again example of like where the social media platform is being utilized for several things. So one of the example is the customer support. So whenever we face any issue or when we want to sort of appreciate some service provided by a particular organizations, we immediately go, or many of us immediately go to Twitter, Facebook, and try to sort of put our comments there. So this is very essential for several companies. I think if you realize, all of the companies are actually on just sort of this kind of a sentiment and or this complaints. For example, again, if there are, let's say that a lot of positive sentiments has been sort of being reflected in the social media, tries to drive the shares price of many companies. The trading it tries this kind of a sentiments, whether there is positive sentiments to companies. So then, accordingly, that it might sort of grow in not facts. Are a reaction which are uh, over the social media form. Sincere the medical professionals to really understand that what kind of drug combinations might create such issues. So there are a lot of such kind of platforms where people discuss these kind of issues, and analyzing them, understanding them is a crucial which you can understand requires the process. You see your face where okay.
Yeah. Now I move to slide number 9. I think you are facing some network issue.
Okay, you have moved to slide number 9. Okay, fine. So this brings to the the question of that what do we mean by this NLP? So why this word of natural language? What is the meaning of this natural language? So basically, that all of us perhaps understand that the sort of that we all understand, but when we want our computers or the machines to sort of understand what is being written, what is being spoken, that automatically, and so they should be able to generate should be able to speak in natural way as the human beings do. So all such methods, or we can sort of say that and we several like to study and then that is where you will see that there are several disciplines actually but known by different names, computational linguists, computational psycholinguistics, speech recognition, linguistics. So they all study, and then they core of it that they want to understand that the different forms of the or the different structures in the natural language. Understand this, please move ahead, Ranveer. Mm.
Yeah. So slide number 10.
Like, you can say that there are, yes, three broad sub areas, and one of the area is the cognition, but we in this talk or in this domain, perhaps we are not really cognition aspect. It's basically that how do we acquire, comprehend, and generate. If interested, I have given a link which you can read and I try to sort of understand that aspect. And there are components which basically we are very interested in what we call the natural language understanding generation. General understanding involves to understand the common structure of the language and able to extract informations. And the natural language generation, as the name says, that you need to sort of able to generate the similar sentences. By default, natural as a language understanding would be there. Okay, please move ahead. So this is just an example of the machine which actually works as an interface. You need to really understand the source language, that what is the source language, what is the structure of it, the syntactic and the semantic structure of it, and then you are able to generate the sentence in the target language, and there also you need to understand the syntax and the semantics of the target language. So the machine translation is a good example where you can see the interplay of natural language understanding and natural language generation. Please move ahead. So yeah. So now we will move to move to the second part, where what this says is that why the NLP is hard, and I will try to skip through that few examples. Yeah, Ranveer, please move ahead. So in summary, let's say that if we want to uh, say that why the natural language processing is hard, so there are 3 points. So there are multiple intertwined levels of NLP. As we are going to see in some of the examples next, we will see that there are multiple levels of NLP, and each level we will see that there are a lot of ambiguity. And since these levels are connected, so the ambiguity increases or multiplies. And another issue comes is that for practical purpose, that we or purpose of, let's say, that the machine learning, if you want to use uh, uh, if you want to use, then we have to have the data, the appropriate data, and also it should be annotated properly so that we can really train good machine learning models. So, so now, just to understand some of these things, uh, so let's look into the two sentences. And so the first sentence says that I made her duck, and second sentence says the time flies like an arrow. So for the first sentence, what is the meaning of it? So Ranveer, can you just press enter? There's an animation. So yeah. So there are two questions. That what is the inference of these two sentences, and whether all the inferences are meaningful or the grammatically correct. So for example, the second sentence, the time flies like an arrow. It may sound weird, but when we understand that what is the sort of the semantics of here, then we say that okay, this is something which is meaningful. And the first sentence says that I made her duck. Now, what is the how many inferences you can make from the first sentence? Let me please move ahead. So there are a few interpretation. You might think maybe more. So the first inference is that I cooked duck for her. The second one is that I cooked duck which is belonging to her. And then the third inference you can do that I caused her to quickly lower her body. So maybe you have thrown something towards that particular person, and then that person has to sort of save herself. She lowered her body. So these are the different interpretation, and if I don't have any context apart from this particular single sentence, any of these three interpretation can be there, and maybe you can think of few more interpretation. So there is an ambiguity, inherent ambiguity built in here. Please move ahead. And one of the reasons that why this ambiguity is here is because the way we are trying to group different the noun phrases and the verb phrases. So this is again the core problem of NLP, that given a sentence you want to a different the phrases structure so that if after breaking them into the phrases, you would be perhaps able to make a meaningful inference, as well as it will also tell that whether a sentence is a grammatically correct or not, whether it follows the syntax of the particular language. So now uh, and as you can see that because I can break them into this multiple way, I can group these different phrases in different way. Each of them will lead to the different meaning. Yes, Ranveer, please move ahead. So there are a few examples that so the first example here, it says that there was a movie which was very successful on the box office, and that movie, the one of the actress called Anne Hathaway, and she performed well. there, and then there was a lot of positive sentiment towards the movie and the actor. What lead to in the algorithmic trading? If you see that there's a lot of news article talking about a very positive, that lead to the significant price rise of the Warren Buffett's, which all of us are aware of, his the financial company, the Berkshire Hathaway stock. So again, if you don't look into the context, if you just only look into the keywords, then you may face this kind of a problem. And then you can see there's another example which again shows that in the two sentences are exactly the same. Only thing is that when we have that, how we are going to parse them, or what is actually written here. Based on that, the association of the day is actually changed from, in one sentence it is sort of referring to the monkeys, in other to refer to the bananas. Please move ahead. So then there are several. So for example, the morphological ambiguity is there. So for example, you have this word impossible and another word which is important. And if you try to sort of see that, okay, in one case, the M and the possible, these are the two morphemes or the two substructure in the word, has certain meaning. But in case of the important, that is not the case. So again, the everything looks very simple at the surface level. Both the words looks very similar, but they don't follow the rules of similar word structure. Then for example, and these are the like morphological issues actually may play a significant role in case of when you're trying to analyze the social media text, because I will come to this point, trying to show some of the examples from the social media cases. Now another example I want to emphasize here is that the last example where this sort of says that the call Ram a taxi. So again, and this kind of an example is going to be very, very because it's in a true sense not a complete sentence, but there is a lot of things which are hidden, and it's not meant to say that the Ram should be called as a taxi, but it just means that you need to call a taxi for Ram. And so this is more like the way we speak and then the way we write. So so this again, but in several contexts we might see such kind of sentences appearing, and we have to have a pragmatic view or understanding of the language so that we can really make the correct inference. And these are like not very simple, and it's not really easy to learn, and these are the reasons which makes it the natural language processing difficult for any the machine learning algorithms or any rule based algorithms. It is difficult to really look for or understand for these different types of the ambiguities, which are, again, if you see these examples carefully, it's not that these are like the independent each of the ambiguities can be independently resolved, and then you can put into the sentence and infer them. Many of these examples sort of reflect that you have to have looked into each of these components together. Please move ahead, Ranveer. Yeah, so in summary, you can see that there are different levels of the NLP. The first level is the word, where you if you are doing the speech processing, of course, then you need to look into the phonetics and the phonology. But if you are only looking at the written sentences or written, semantics may not play that role. You have to look into the meaningful component of the words. For example, we have to study possible. So what kind of a different sub components which has the meaning. The syntax, which is a relationship between the words, the study of the sentence and the phrase structures. The semantics, where we are looking for the study of meaning. So first of all, we have to look into the meaning of words. The and important the social text is largely less limited, and that actually really create a challenge the regular NLP methods to infer anything or extract the used information. Some also involves reading about the word. What was and and or social uh, whether already see whether the slide seen. I will just now specifically in this corona to how any of you, somebody wants to perhaps understand that what are the kind of questions has been asked. Sort of, one. Yeah. So, to give you example, population and the social, and an average of 3 hours is being spent on social media, and not only viewing, but it's also contributing on those platforms in several manners. And in the bottom panel there are some examples which shows that for each of the number of how many active users are. That means so this status is being generated because we are sort of on these platforms, on these social. And to give you some more statistics on it, Ranveer, please. Example, it's about 1.3 billion amount of data. So this is about 10,000 tweets per second. So this data actually I'm trying to collect today for. This says that about 10,000 per second is being coming here, and where I on these social media platforms, you see people speak in the different languages together, and very common for am I audible?
Yes, sir. Yes, sir. We are able to hear you.
Okay.
We are able
Okay.
to hear you.
So and yes, uh, in depending on let's say what kind of a platform or social media platforms we are using, the styles also vary. The topics that we are going to discuss that, and another curiosity is that it also often brings the biasness, noise, a lot of abnormal data which is being there. So if it generates. So we have to understand few things here, that each of these components, each of these 4V in itself is a challenge, because it generates huge source of unstructured text data. It comes with the very high speed because a lot of data is being generated every second. It comes in a multiple varieties in terms of the language, in terms of the writing style, in terms of the topics which is being discussed, and also it also brings the so many people's personal biases. The lot of there will be noise and so on. So if we want to understand that what is being taught, whether those issues are important, whether some of these things can create a uh, uh, social security issue, whether it can be a some health issues which is sort of coming up. For example, perhaps the corona or the COVID was spreading in China, maybe people were discussing about all these kind of symptoms, and if actually the news were really taken forward, perhaps people would have understood or realized this pandemic, or the potential pandemic much earlier. And that actually answered this question, that why really we want to understand what is being taught. Uh, so, so the trending topics, real-time event detection, rumor detection, fake news detections, the sentiment analysis. So all of these are sort of self-explanatory by the names of these applications, by that why it's important to mine or understand the social media text. Please move forward. So now once we understand that, okay, these are the important things we need to really mine and understand or analyze these social media texts. Uh, so it's not that the NLP is sort of, is there from today. When the social media platforms were not there, people were trying to sort of analyze the different news articles, the research articles, and so on. And in that process, people have developed a lot of tools, a lot of resources. So can we use such resources? So so this is one of the example uh, I'm trying to sort of highlight here, but then there can be similar such examples can be given for other NLP tasks. Uh, so this example is related to the part of speech tagging. So you have a sentence given, and you want to see that for each word, what are its part of speech. And in this particular study, people have taken some sort of a standard, very off-the-shelf tool, and then see that what kind of a performance is being obtained on social media text. So when they compare, so the first row of this table says that, okay, if you assume a very basic assumption that if I try to assign each word its most frequent part of speech tag, okay, then it only gives an accuracy of about 18% or 19%, which in case of, let's say that the regular news articles goes into the range of 80%, about 80%. So you can see that such simple baseline, which gives a relatively good performance on the news articles, is not giving such performance on the social media text. And then there's a tool from Stanford University that gives about 80% on this particular social media platform, or the text coming from the social media platforms. On the other hand, the same tool gives about 90% accuracy. There is a significant drop. So that tells us that maybe we need to do something more than just directly using these. And then if you want to do something different, then we need to understand that why and what is the special in the social media text, so that you can accordingly tailor your model. So that's what we are going to understand from these some of these few slides. I will try to wrap up in another about 8 minutes, 10 minutes. So one of the things is that you see that the social media text, there are various platforms, the various flavors of the social media text. So one of the is you have the multiple authors contributing and writing a content. Then you have a single authored blogs, which is relatively bigger than, let's say that micro blogs like a Twitter, which is a good example of the micro blogs, where you have some limitation of, I think right now it's about 250 characters. Earlier it was 140. Social media forums, for example, YouTube, Facebook, and so on. And each of them, there are like a lot of these the comments which is being generated by the users. And if you look into the just a very simple thing that, okay, how many words it contains per document, and this is one simple analysis which is done. So you see that in a Twitter it contains about 12 words. But if you go to forums or the blogs, it contains about 150 words. So at least what it says that the varying or the different flavors have different amount of context present in them, and if you want to infer anything from them, whether you will have a sufficient context or you will have a very limited context. So at least this analysis tells you that. Ranveer, can you please move next? Next. And also, if you see that what are the predominant language which is used in the different of some of these different flavors of the social media platforms, although you see that the English is somewhat dominant in each of the forums, but for example in Twitter it's only half of the, let's say that the total documents or the is written in English, and rest others are actually in different languages. So again, it tells that, if you have to sort of, understand, for example, for Twitter, or you want to understand from the other comments or the forums, maybe you have to sort of focus on the other, the languages from where, and you have to develop the tools which is sort of more the language specific, uh, uh, which is actually more language specific. Can you move forward? Yeah, and this is sort of, the another example that the free form uses of the language. So the in social media, you are because of its nature, for example, Twitter, because there's a limited characters, so people brings innovative way to write a word in 2 characters. Uh, so, for example, this in the screen you see that how the tomorrow or the what are there's a lot of inconsistencies, and it actually leads to that lot of out of vocabulary, uh, because every time people might invent new way to write a particular word with a few characters, and that you may not be able to make it which can come sort of take care of all such instances. So you have to have in some way to understand that, or you may have to sort of normalize each of these variants into a single form, so that you would able to make the correct inference for your target task. Please move ahead. Uh, and an example which says that, so in different the platforms or the forums of social media, you have the word length which is more or less very similar, but the sentence length actually varies. And when you look into the percentage of out of vocabulary words, they vary a lot, and without normalization and do some sort of normalization, it reduces somewhat, but not significantly. So that means that this of the variants which are a very big challenge even today. So although this study which I have taken it from the 2013, but I think this is still one of the big challenge for NLP dealing with the social. Uh, Please move ahead. So in summary, you can understand that there are distinct flavors. There are free the language in these platforms where you have inconsistent spelling. You can see the adoption of new terms, the usage of slangs, usage of the non-canonical short forms, abbreviation, and many of these discussions of the content is written in a more like a conversation. So in conversation, often we speak in a short sentences, and leaving out some of the obvious part. Uh, so so in that way, extracting information is a big challenge. There is a no grammatical structure which is being followed. Research articles where there's a proper grammatical structure, and that is being exploited by the different NLP tools, which here in social media perhaps we cannot do that. And then each of these platforms has some sort of a spatial symbols. For example, different way to use the tags, emoticons, and so on. So that also sometimes present a lot of context, a lot of information, how to include them, on how sometimes we need to include them, sometimes we need to exclude them depending on our target task. But that really would require the understanding your problem statement and how these tags are actually being used in reference to those tasks. Okay, please move ahead. I think this some of the very basic things. Once decide, actually gives you a fair idea that what are the challenges and to resolve in my and highlight that what are these challenges, uh, and uh, and if you want to start with some of the very basic things you have to do is you have to sort of do the tokenization of your data. And what it means that you have to say that where is the sentence boundary, where is the word boundary. So for example, New Delhi, whether New Delhi is a two word or a single word, so that you need to I mean, not you means that your model or your tool needs to sort of make a differentiation that New Delhi is a one word, but new book is a two words. So those things, that kind of a segmentation or tokenizations need to be done. Normalization is the what I call is that this lexical variance to be mapped to one single word or canonical form. And before any of these things, you have to do the create a corpus for your own task. You have to design perhaps some features, and then only you can talk about the models. Go next. So this is an example of how yes. So this is an example of how this the POS tagging performance was improved. So the earlier I have so POS tagging performance was very poor with the off-the-shelf tool, but this particular paper has tried to improve using the tweet data and some other similar social media platforms data, and it managed to sort of improve the or reduce the error by about 40%. How it is able to do that? So this is the point on the right panel, which is the point which is important. That first thing is that it has created a domain specific corpus where the any of the ML models can be trained. So the for example, the third row, the Stanford POS tagger, giving very good performance for the news article kind of a data. They actually trained on such data sets. They are not trained on the social media text data set. So when the authors have created a data set and annotated them with appropriately, and then they have sort of trained their model, very similar model, they were able to improve the performance and reduce the errors. So the creation of the domain specific corpus is important. Then they have also done few other things. For example, they in Twitter, there were some specific, like you have the retweets, you have hashtags are being used, you have at the rate of usernames are used. So those things they need to sort of give them the specific tags. They have processed them, pre-processed them, and then make sure that those words are appropriately considered in their model, so that it actually learns that whether it's the word, I mean, if those words really need to be considered or they are part of the context. So for example, if I say something at the, you look awesome, in that case, this awesome has a, let's say, some meaning. But if I just say perhaps hashtag awesome, it and that is the only thing there, I don't have any context, then maybe perhaps I should ignore such occurrences. So that kind of a specific processing has been done. And one of the things they have done is that to get the normalization, they have performed this brown clustering to consider these out of word vocabulary words, how they sort of understand and map those words and group them together so that they can be normalized to the proper the words of the vocabulary. So these are some of the steps they have actually taken, and that actually lead to the performance improvement. Please, Ranveer, next slide.
Ashish, maybe can we have in about 5 minutes?
Yeah. So this is the last slide actually.
Oh, okay.
So uh, mm, so as I said that this talk is sort of primarily to make you aware that is there while dealing with social media text. And just one example, simple example of that, how a very simple, or let's say some understanding of a corpus and its structure actually helps the improving the performance of the basic NLP tools. And if you are interested to sort of understand more on these, you may look into these two references. That would be, I think, give you fair enough idea. And I will particularly highlight that this title of uh, the first paper, here the difference is deliberately written incorrectly because to sort of emphasize that these are the variations which comes, and while processing the social media sources you have to be very, very careful with that. So you have to really map these variants to its true word or the canonical form of this word. So with that, actually, I end my talk, and I'm sorry for the disturbance because of caused by this network. I will see tomorrow that how it can be sort of minimized.
Yeah, Ashish, I think
Yeah.
it was very, in spite of this, say, I think you have touched upon, say, different challenges they wanted to address while, say, handling with social media. So it was, I think, very insightful presentation. So I think if from audience we may have, say, time for one or two questions. I am not able to see chat box. I will just. If participant, please, if you have say some questions, yeah, I think please, yeah, quickly can you please post the question at Dipendra. Otherwise, also tomorrow, Ashish will also be taking another session. We can continue with the questions. So the question is how to work with regional language based tweets or posts apart from TF-IDF or count vector, and what to back. Ashish, this is the question from Dipendra Bhushan.
I think this question seems to be very, very generic in the sense that so first question is how to work with regional language based tweets or posts.
Mm-hmm.
So if the student, I mean, I think I think student is aware of this different way to generate. When I would have sort of tried to understand what is the intention of this question, because this question is very, very generic, that how to work with regional language based tweets or the posts.
Okay.
I don't know. I want to understand that what is the sort of intention. Is it the student wants to, or let's say the participant want to understand the obtaining a vector representation for words, or what? I mean, if it is to understand the regional language.
So it seems from his question, it seems like say when there is a post in say regional languages other than English, how to probably handle such posts in general, because he was also telling apart from TF-IDF, word count, say vector count and word to back, say how to handle regional tweets. But I just wanted to supplement on this question, Ashish.
Yes.
So one way of handling, say we are also dealing with tweets in Hindi, Assamese, and Bangla. So for doing sentiment analysis. So first stage that we do is something like language identifications. So what is the under language? It say regional language or Indian languages. Then once we have this, then again one way of working is directly we try to apply these deep learning models on these noisy data sets. But then another is like, but in that case we get limited performance. Then what we do is we try to normalize this noisy text, building language specific models to normalize. Then once we something like transliterations and so on, then once we get a normalized text, we apply the general models. Okay. So this is one of the approach that we use. But Ashish, there are many questions.
Yeah, I will add on to this one that.
So Ashish, what I'm
what integer value you get from the socket
See, Ranbir, all question will be answered subsequent classes. Okay. So skip to next and continue.
Because of the time limitation, so what I will do is I will mark all these questions, and maybe tomorrow before starting the session we'll take up these questions.
Yeah, fine.
So participant, I think please excuse us because of this limited time. We will be I will be say marking these questions, and say if we have time to, then we'll try to pick up some of these questions and try to answer in tomorrow sessions. Okay. Thank you.
Sure.
So next we have Dr. Vijaya Sarathy, next speaker. So he will be talking on cross-lingual, say, information retrieval. You might have already seen, right, in the social media data. One of the major challenges is code mix or multilingual scenario, because the text are having multiple languages and so on. So Ashish has given very deep understanding on that. So now how to do some kind of retrieval process on such environment. Okay, so Dr. Sardi will be talking about it. But before that, I just want to briefly introduce Dr. Sardi. So he is presently working as an associate professor in the Department of Computer Science and Engineering, IIT Guwahati. He did his master's from IISc Bangalore and the PhD from IIT Kanpur. And prior to joining IIT Guwahati, he worked with various industries like Tata Research Development Design Centers, Sunset Computer Associates, Tenet High Tech Private India Private Limited, etc. His area of interest include theoretical machine learning and data mining, kernel methods, etc. And so one more information I want to share with participant is that he's also working with analyzing RTI data and cricket commentary. So in the morning session, one of the question was how to do machine learning on sports data. Okay, I think so he can also give some lights on that. So with this short notes, Sir, this I'm handing over to you.
Yes, thank you, Ranveer. Can you hear me?
Yes, sir.
Hello? Yes, yes, yes. First of all, thank you very much for the ISEA organizers, then Dr. Ranveer, Professor Sukumar Nandi, and all the let's say, team associated with this one to give this opportunity for me to present uh, the kind of things that we do at my lab. But this particular talk, I will be very briefly on the fundamentals of the learning methods, and I'll depart uh, from the uh, from the general kind of discussions and be little specific, and will be able to give you some understanding of how these learning methods essentially work. And in the morning session, I remember that Professor Nandi has very kind of that varieties of data are there. That data is incomplete, data is inconsistent, it is noisy, and it is multimodal. Right? So that's exactly where say my talk will be in terms of handling multimodal data. Right? And before that one, I just wanted to ask the people that my screen, is it visible or not? Ranveer?
Sir, yes, sir.
Are they
Visible.
open? Yes, yes, yes. Okay, fine. Then I'll just kind of in fact, what from that particular context of multimodalities, I will try to introduce to you the multi-view learning and its applications. And its applications, to be very specific, I'll just kind of give you uh, these applications that can, let's say, I assume that you all can see my screen. So this particular figure essentially shows that in our information retrieval engines, the search engines, today's search engines, we have the ability of giving any query, and this query can be text as it is shown here. I'll just highlight with the marker so that you can all let's see this one. This is the query of the text, and the retrieved results are not the text. Instead, they are the images associated with this text, with this highlighted text, which means that we are posing the query to the search engines in one context and asking the search engine to retrieve the results in completely new data form. In this particular example, query happens to be a text and retrieved results happens to be the images. This is another example that let's say we have over here, and then let's say the associated results are images. Right? And we have seen multiple such examples. It is not only about images. It can actually be given a speech as input, giving let's say videos as output, right? In YouTube or any such kind of thing. So the multimodality has become much more prevalent and actually has percolated to the general let's say users, and the the barrier of this data and its complexity is hidden from the users altogether. Right? So we will not even let us think that we are actually giving one form of the data and then we are returning another form of the data. These are very, very complex tasks, involved tasks, and they need to be understood how these things work in practice. In addition, it need not be about, let's say, audios, videos, images, text, and so on and so forth. It might be much more advanced, like geographical coordinates. Like if I voice control, and the set output will be the maps. And such kind of applications we have been seeing, and then we are actually interacting with them seamlessly, right? And in that particular context, what is it that we wanted to know is that how such kind of retrievals actually happen, sir, right? Is it, let's say, some systematic procedures are there, or how do they actually handle multimodal data, which essentially is complex, sir? That is the fundamental question that we want to look at. From that perspective, I'll just go back to my presentation and then see that when we say that multimodal, I will actually call that as multiple views. Views in, let's say, much more let's say restrictive sense, and then I'll actually explain it. And I'll give you the examples of what are the multiple views, and then where these are used in, let's say, the machine learning, be it in supervised learning, be it unsupervised learning, be it in, let's say, any other forms of learning methods. And we'll also touch upon what is data. Is it a single view? Is it a multi-view? Is it a single modality? Is it a multi-modality? Then we'll take up a specific example of dimensionality reduction, how it works in single view methods, how it works in multiple view methods. That's exactly what we'll try to look at it. And then let's say go back and then let's say correlate with respect to the retrieval kind of framework. So coming to the definition of views, what are the definitions of the views? Is that views as per the dictionary meaning, if we just take the as it is dictionary meaning, the ability to see something or to be seen from a particular place. This is very important, and we will look at with some examples. It also says that a particular way of considering or regarding something, an attitude or opinion. So these are the kind of general English specific meanings pertaining to the views. But from the perspective of, let us say, machine learning, from where we want to technically examine from where the data is coming from. And that's what, let's say, the below bullet points essentially guide us. The data is, if the data is acquired from only one sensor, then it forms a single view of the data. If the data is acquired from one sensor but multiple perspectives, then it forms multiple views of the data. And I'll give you, for each of these things, I'll give you examples, right? Because I'm using words like multiple perspectives, and you might be at this point in time thinking what these particular perspectives are, but I'll actually kind of elaborate with examples. Then when it's not always about data being collected from the sensors, it's also about data that is derived by observing the data from the single sensor, which forms the multiple views. Data acquired from multiple feature extractors forms from one sensor itself, forms multiple views. So essentially, we have multiple feature extraction methods that are the underlying data is collected from one view. That's what I mean to say. The data acquired from random sampling, you have only one view, but you essentially sample the data and that becomes multiple views. Data acquired from multiple sensors is in a much more broader context, is what is multiple views. And in the context of the general setting, what we have, let's say, given as examples, the text being given and images are being brought out. These are all multiple sensors because text is written by someone and images are actually captured by the some other sensors. videos are captured by some other sensors. Audio streams associated with the videos are captured by some other sensors, and so on and so forth. They are the natural examples of multiple views of the data. Now we come to, let's say, specific examples from this, let's say, understanding, and then see what these multiple views essentially are. One sensor, multiple perspectives. So we have one camera, and then one person is there. And if you look at the central picture in this particular thing, there are 3 rows. If you look at the second row, the middle row, we have captured the face of this person when this person essentially is viewing the camera right in front of the camera. Now the top row essentially looks at, shows the same camera, which is the same sensor, but when the subject, he has changed the let's say poses. So in the image processing literature, these are all called poses, and multiple poses are there. And but over here, what we are actually interested in is that each of these things is a distinct view. And one more point I wanted to emphasize is that each of these 5 figures are representing the same underlying person. That is the most important point, which means that all these 5 images are referring to this lady in this particular slide, right? But their views are different, and hence it becomes a multiple views, even though it is the same picture of the same system. We have discussed about one sensor and multiple perspectives. Over here, the meaning of the perspective is that using the same sensor, I have asked the let's say changed the way in which I have captured the photograph. It can also happen that using only one sensor, I can actually derive the data. And in this particular thing, what is the meaning of the derivation of the data, I'll just explain, is that if I have a web page and a collection of such web pages that is given in figure 2, assume that, let's say, I have a collection of such web pages. So one representation which is given as is in the figure 3, that essentially is the matrix form that is written. So let me just look at terms versus document matrix, right? In this matrix, what I'm actually looking at is that only one web page, and I wanted to look at that this term in how many documents it's appearing. Second term, how many documents it's appearing, and so on and so forth. So this you can actually think of as a term document matrix. So from the multiple web pages that I have, from figure 2 and then several such web pages are there, I have constructed the term document matrix. In addition, using the same multiple, let's say, images or let's say web pages, we can also construct another form of the data. That is exactly what I wanted to say to you, is that I have kind of derived a graph, and this graph, which essentially is nothing but which web page is essentially pointing to which other web page. In this particular thing, if you see the blue highlighted text, which essentially points out to, if you click on this one, it will lead to another web page, right? So web pages are represented as a nodes, and the connections between the hyperlinks between 2 web pages are marked as the edges in this graph, and hence I can represent the collection of the web pages as graphs. So on one hand, given this data of collection of web pages, I am able to represent them in the form of matrix, term document matrix, or a graph. And these 2 views are distinctly different, and they are all derived from the same underlying source of the data, which is multiple web pages. So this derivations also leads to multiple views, and you might actually see that the information each of these views is bringing to the table is distinctly different. The other example essentially is that one sensor and multiple features. For example, if I have this image in this image processing domain, if let's say this image needs to be kind of represented, traditionally histogram features be extracted from this given image, which is presented in figure 6. Our edge features are extracted from this image, which is represented in figure 7. Our histogram oriented gradient features are derived using figure 8. So there are multiple feature extractors that you can actually employ on the given same underlying original image, which is over here in this context figure 5. So this also becomes multiple views. So what are the multiple views over here for me? Histogram features, edge features, HOG features, and so on and so forth. Each of these things once again brings distinct information, same underlying of the same underlying image. Right? That is what is the fundamental point we wanted to understand. Then random sampling also can be thought of multiple views in the sense that you have 10 data points and you have sampled it distinctly. For example, over here points 2, 3, 4, 5, 6, 1, 2, 3, 1, 2 up to 10. And in another let's say data set, I have sampled the same 10 data points I have sampled in different ways. But here, if you look at the data point 1 is not present, but over here it is present. Likewise, I have formatted the multiple views. When we're essentially talking about multiple sensors, this is what becomes much more interesting, and that is what exactly is used in the real world applications. That the images and then the associated text. Note that images are essentially captured from a distinct sensor versus the text is authored by the some other let's say sensor. Maybe it's an author, human, who has narrated about this particular image. And same is the case with over here. I have two images on the first row and explanation about the images, the respective images form the views. Right? So multiple sensors of the same underlying object, and then each of these, be it image or be it text, they all refer to the same object over here, right? And multiple authors you can also think as they are bringing as multiple views. For example, over here, if someone has asked you to write a kind of text on a subject, over here, Mr. Sherlock Holmes, it's English description of this particular description or chapter forms one view versus distinct language of the same context form the other view, and so on and so forth. Over here I have four distinct languages. The underlying subject, which essentially is that writing a book on Sherlock Holmes, is identical. Right? But they all bring distinct information. It need not be that they bring identical information. And it may happen that let's say we have multiple sensors and multiple authors. Over here we have, in this particular example, we have two images need not be captured from this identical camera, which is essentially the same sensor. And similarly over here, this image and then corresponding drawing need not be drawn by the same author. So which means that multiple sensors, multiple authors, and the data that is derived out of these things. So to summarize, what we have is that single view data, what it means is that data must be generated from one sensor, one source, one perspective, one distribution, and hold the assumption the data is independent and identically distributed. Any of these above mentioned examples forms the single view. But on the other hand, the multiple views, they essentially kind of depart from these things. Any of these, let's say, things that is written over here, there is a departure, then it becomes multiple views, right? And to give an example, let us say that we will try to denote what the data looks like. That I have data points, n data point, which essentially is written on the first row of this table, x1, x2, x3 up to xn. These are all the n data points that I have. And then on the rows, let's say in the column view, Under the column view, 1, 2, 3, 4, 5 up to V views are there. So essentially I have V views and N data points are there. What it means is that data point 1 I have collected from view 1, view 2, view 3, view 4 and so on and so forth, view V. And now it might so happen that I have associated class labels for this data point x1, and it must agree that all the views must agree that the label of this data point x1 must be y1. That's what is the main assumption in this one. So in this particular way, this data is constructed for multiple views, and the assumption in this multiple views is that the data point in one view, if there is a data point, it must exist in all the views. It is not the case that x1 is available in view 1, view 2, but not view 3. In all other views, it is existing. Except view 3, every other view, my data point x1 is existing. That cannot be, let's say, that cannot, the assumption is that every view must have the data point x1. And same is the case for all the data points. But this assumption doesn't hold for random sampling. Well, that is why we'll see how the objective essentially is that the objective of this one is not as how to collect the data from multiple views, but if we have been presented multiple views, how we can learn, let's say, learning algorithm, how we can build a learning algorithm. That's what is the main thing, right? So the other assumption that let's say there is that every xj must be present in all the views that we have explained, and multiple views data set is represented as in the form of below. Xi essentially I have written over here xi. Let me just mark it. Xi is the data point. What it means is that it is available in all the views. Xi in first view, Xi in second view, Xi in third view, and so on and so forth, all the V views. And the label corresponding to that Xi is Yi, which means that every view must refer to the same label. And what it means, I'll go back once again, is that in this particular example, even though I have 5 views over here, each of the view is referring to the same underlying person. That is what is the label. So what is this? Then given this multiple view data sets of this form, this particular matrix, if somebody has presented to me, then how the multi-view learning, what is the multi-view learning algorithm? So I have explained you multiple views of the data points. Then what is the multi-view learning algorithm? So these multi-view learning algorithm essentially is that it is building the multiple learners on a data set and combining their decision. This is one way of obtaining this one. Or building multiple learners on multiple views of the data set. Multiple views of the data set is what is the main underlying point and combining their decision. The underlying observation is essentially in each of these things, be it in multiple learners from the single data set or multiple data sets, is that the multiple learners are used. I will essentially kind of elaborate at a later stage, but you might be wondering that how can say be possible that one data set is used. You can also let's say think of as concatenating all the data points and then forming as a single data set and build the learners. But they have serious kind of pitfalls if we do naive learning strategies. What it means is that I combine all the x1s of all the views and then let's say obtain my x, particular x. If I combine all these things and then form x1, concatenate it and then forms an x1, it might be a single data set, but it will not essentially be very what I mean to say is that it may not the resulting learner may not essentially be able to take advantage of the information that is present in multiple views. We'll also see why that actually can happen. But on the other hand, if we build multiple learners on the multiple views, which means that treat each of the views differently and build multiple learners, then you will be having much more accurate decisions that can be taken on the multiple view data sets. So how to build multiple learners is what is the main question. And the way that let's say that can be visualized is that building one learning function for each view independently, which means that I'll go back over here and then ask you to build, let's say, one learning function for this view. So I find an F1 for this one, and I find an F3 for this one, and so on and so forth. So essentially, I will build V learning functions and then try to combine their decision. That is one way of building the multiple views. Other way, that is what is the first point says. Building one learning function on each view independently. That's what, so I will build a learning function for first view. I denote it as F1. Build another learning function on view 2 and then denote it as F2 and so on and so forth. Or the other way is formulate one single objective function involving all the multiple views simultaneously. And this is where the most of the methods essentially take the advantage of the heterogeneous information present in the multiple views. And in this particular talk, we'll actually talk about formulating a single objective function in learning multiple views. So, and I will just not go and digress in terms of the supervised learning and unsupervised learning, particularly the supervised learning. I'll just directly jump to the unsupervised learning and then try to see with specific example, keeping in mind the dimensional reduction, how multiple view learning can be used for dimensional reduction when multiple views of the data is available. That's what is the context of this particular talk, and that's what we'll look at it. From this particular point of view, we are given a data set X, and each data point Xi is in the P dimensions, and we wanted to reduce the dimensionality. And then when you essentially say P dimensions, you can, dimensions are nothing but the features, as explained in one of the talks by Dr. Ranveer, that in the examples of the cars, you will be having features as the number of wheels and then the height of the vehicle, right? So one feature essentially is the number of the wheels, another feature essentially is the height of the vehicle, and so on and so forth. If you have multiple such features, that is represented as the P. I have P features for this data point Xi, and I wanted to kind of reduce them if the features are, the number of features are very large. Right? And in particularly in the real world context, this number of features are really, really large, depending on the context of the data that we are playing with. And the objective of the dimensional reduction is that I wanted to learn a function f which produces a linear transformation. To simplify that, I'll say that I wanted to learn a matrix P. I wanted to learn a matrix P. Oh, I am not able to. Okay. I wanted to learn a matrix P which lies in the low dimension. And when I learned such kind of linear transformations, that matrix P, when I multiply with my original data X, which is given over here, the resulting data lies in the low dimension. That is the optimization formation at a very high level. And how this is achieved, the learning of this matrix P in first the single view and then in the multiple views. So single view, I will introduce very quickly principal component analysis, and in multiple views, we will introduce canonical correlation analysis. Right? So we will look at, before proceeding further, we'll essentially have a note on you know, before going to this one. Ranbir, how much time I have? Dr. Ranbir?
Yeah, about 30 minutes.
Sorry?
Yeah, about we start a little late, so we can continue up to 5. So
Okay.
30 minutes you have.
So 30 minutes I have, roughly. Okay, got it. So let me just look at a note on the single view. Is that one view of the data is available for learning a function f, right? And one learning function is learned. From one view, only one function is learned. So essentially, I have one view of the data, and I learn one function f. Or in this particular dimensional reduction context, I learn the matrix P. What is the thing that is written? So the assumptions in this multiple view essentially is that view sufficiency. Each view is sufficient to learn the task that is given at hand, and compatibility, that the target function, the labels of the views that are predicted is same. This is particularly compatibility is from the perspective of the classification. So I will skip this one. Similarly, these are all from the perspective of the classification. What is the conditional independence and so on and so forth. We'll skip this one. So view sufficiency, what it means is that these presented views are sufficient to achieve the objective that we have. The objective is that reducing the dimensions. From that perspective, we will essentially see that every view we have satisfied the view sufficiency, and we will assume that it is met through feature engineering, through some mechanism, right? And the learning models are strengthened by varying the objective function or optimization methods of the loss functions. We'll look at what it means. Right? This slide is also from the perspective of the classification. So I'll essentially skip that one. What is the main assumption, underlying assumption in the multiple views? But I'll start from this particular slide to explain what is the meaning of multiple view learning. So before going into the actual kind of learning algorithms, I wanted to introduce you to the notations, some basic notations, and then move forward. Given a vector of p dimensions, in this particular case, for example, first dimension is the number of wheels, second dimension is the number of the height of the vehicle, and so on and so forth. So several such dimensions are there. I have one data point which comprises of all these dimensions, and that is what is this data point x. And we assume that this vector x is a random vector, right? Then each element of x is a random variable. Each of these things is a random variable, right? And since it is a random variable, I can actually compute the mean of these random variables, which is essentially given as follows over here. For each of the dimensions, I compute the mean of the random variables. So which means that I can compute the mean of the number of wheels. I can compute the mean height of the vehicle, and so on. For each dimension, I actually have that one. And that is notated as the vector mu, which essentially means nothing but you compute the expected value of the first dimension, expected value of the second dimension, and so on and so forth. That results in a vector which essentially is mu1, mu2, mu3 up to mu p, where p is the number of dimensions. Right? So now the second definition is that variance of each of the dimensions, and that is what is computed in this fashion, that how much each data point is deviating from its mean. So xi, how much it is deviating from its mean. That's exactly the variance measure, sir. And this what is the one, this particular definition is the one which plays a significant role in the dimensional reduction. And in particularly in principal component analysis, variance plays the important role, and then we'll see how it actually plays the important role. Right? The definition of the variance for each dimension is given in this fashion, and we'll see the covariance over here. What we are actually measuring is that how much each data point is deviating from its mean. When it comes to covariance, we have several means, right? Instead, we can actually also see that how each data point x is xi deviating from mu2, mu3 up to mu p is the covariance. That's exactly what we wanted to look at. The pairwise random, the behavior of any pairwise pair of random variables and how they deviate from their respective means, or let's say from the means, is what is the covariance matrix. And that's what, let's say, we try to elaborate over here. That is what is the covariance matrix is given in this fashion. X1, how much it is deviating from mu1, and we will essentially have such kind of deviation from all the dimensions. We multiply with this vector itself. That's what is the covariance matrix is, nothing but that. So which means that x1, how much it is deviating from x1, the mean of x1. X1, how much it is deviating from mean x2's mean. That's what, let's say, we want to say. So likewise, we will try to compute the covariance matrix over here, and in a simplified notation, this is what is the notation of the covariance matrix, right? And in the context of the multiple views, we will be using the covariance matrix, but in the context of single views, we will use the variance, right? That is what we wanted to emphasize. And we will actually see that we have learned what is the meaning of the covariance matrix. But here, if we divide each of these things and normalize this matrix with this form, so what is that? Let's say the resulting thing that is being computed is the correlation coefficient. Correlation coefficient is nothing but we have the quantities over here that is being computed. We kind of normalize them in this fashion, right? So then we'll be having correlation coefficient matrix, and that's what we are essentially interested in the analysis of the multiple view lapping. Right? Or if we wish, or let's say if you allow, we will work with, in the multi-view context, we work with the covariance matrix. In the single view, we will work with variance. That's from that perspective we'll look at it. So now we try to look at what is the principal component analysis. Most of you might be knowing about it, but I'll just very quickly run through this principal component analysis and come to canonical correlation analysis, which is the multiple view lapping. And some of you might be introduced if you have done the multivariate analysis courses, then this is the foundational method. That's exactly what I wanted to touch upon. And how these are used is what I'll also explain in some time. Right? But to come to this principal component analysis, the idea is very quickly I'll try to tell you is that see, I have this data point. Here is one data point, here is another data point, here is another data point, and so on and so forth. I have so many data points, right? So these are all the data points I have. I wanted to see that if I, along which direction, if I project the data, will retain the maximum variance. That is exactly what is the context of the principal component analysis. So which means that give me a direction along which, when I project all the data points that are given over here, when I project them, the resulting the resulting projection will retain maximum variance. That's exactly what it means. So I'll give you an example over here. If I naively project, very quickly I'll give you the idea and then we'll move forward, because I know most of you might be familiar with this PCA. So if I try to project all the data points along x direction, x-axis, so I project all the data points here. So likewise, I try to project. So the maximum variance essentially is this one. You find the mean of the projected data points. Let us say this is the mean, and you find the variance. Let us say this is the variance. So this is what you will be having, the variation. And so in this particular case, we chose to project along x direction. Why only along x direction? Why not y direction? Okay, let us project on y direction alone also, and try to see what is the maximum variance that will be resulting. Roughly, I have, let's say, tried to draw this one. Now the question is that why along x direction and or let's say along y direction? Why not any other direction is what is the main question. And if that is the case, I can project the data points along this line or along this line or along the green line or any other line. Right? On any direction I can project the data points. Now the question that I wanted to ask essentially is that what is the direction along which if I project all the data points will result the maximum variance. So for example, if I project along x-axis, I have, let's say, variance v1, vx1 or v1. And if I project along y-axis, I get v2, variance v2. And if I project along this direction, I get v3, v4, v5, v6, or v7. So on and so forth. There will be infinite such kind of directions. So now the question that we wanted to ask is, among all these v1 to v7, which one essentially is the maximum? Let us say if you say that this is the maximum, this direction retains the maximum variance, then that becomes the first principal component. Which means that it retains the maximum variance and all other directions can be discarded. That is what, let's say, we wanted to find out in the principal component analysis. So which direction? Give me that direction along which I should project the data. That is what is the main thing. Now I'll come to that and then set the context so that we all understand what is the context. So now to construct the direction, to construct this direction, I must essentially explain this direction in terms of x and y. That is what is the main thing, right? So I can construct this direction in terms of x and y, and that's what we will try to do that one. So I will construct a line by fixing these, let's say, constant. Let us say 4 times x1 and then 4 times x plus 5 times y. That becomes a direction, and along that direction I project all the data points. 4 times x1 and then 5 times x2. And you say x1 and x2 are these things. So now what it means is that I choose a constant vector, and I have been given the data point x containing all the p dimensions. Now I will express these two vectors in terms of linear combination. So which means that c1 times x1, c1 times x1, c2 times x2, and so on and so forth, cp times xp, which essentially is this linear combination. So this linear combination is nothing but c transpose x, which is in the form, which is the linear combination. I will try to find its mean, which is this one, and I try to find its variance, which is this one. Now why I am actually doing this one? I wanted to find these c's that maximizes my variance. Right? From this context, I am actually looking at that one. So now I'll try to very quickly set up this objective function and then go ahead without wasting let's say much of the time in terms of the notation. So I'll try to see that maximize the variance subjected to the condition that it's a unit vector. So that's what is the main thing. And over here also, sorry. And over here also we have seen that I wanted to find a direction, which means that set of constants, which means that I have been given a direction over here, along which if I project my data points onto this direction, will result in maximum variance. I must get maximum variance over here. So you give me that C, which gives me maximum variance. That is what is the context. So I'll go forward and then see that is what is the objective function. And then the constraint essentially is that this vector along which we wanted to project is a unit vector. Right? Now I will try to solve this optimization problem by invoking the Lagrange multipliers and then find what is my C function, the vector C. It so happens that my vector is nothing but the C vector is nothing but here is the C vector. That it is the first eigenvalue corresponding to the first eigenvector corresponding to the largest eigenvalue. That is what is the main thing. And then how can I say it's the largest value? Is that, see, I know that let's say this is the Lagrangian multiplier. So this is the Lagrange multiplier. Let us say that now sigma times C is nothing but lambda C1. This I will substitute over here. Instead of lambda C1, I substitute lambda times C1 prime. Right? Lambda times C1 prime. And here C transpose C must be equal to 1 because of the constraint. So it becomes 0. So it becomes my objective function becomes C transpose lambda C1, C1 transpose lambda C1, which is the lambda, which must be that first eigenvalue, the largest eigenvalue, and the eigenvector corresponding to the largest eigenvalue is the first principal component. And then I must project all the data points along that direction. That is what is the basis for the principal component analysis. So this essentially goes on. So the underlying solution essentially is that construct given the data points. So let me tell you the way in which it will work is that construct the covariance matrix and find their eigenvalues and eigenvectors. That becomes your principal components and the principal directions.
Sardi,
Yes.
you have about 10 minutes.
Yes, I'm coming. Thank you, Ranveer. And I'm almost there in terms of the multi-views. So the multi-view learning here, what we'll try to do is that we have view 1 and we have view 2. The exact identical thing that we do, we essentially try to do the linear transformation. We apply the linear transformation on view 1 and we apply the linear transformation on view 2 and then try to maximally correlate these two, let's say, views. That's exactly what we try to do in multi-view learning or canonical correlation analysis. Right? So we'll come to the notations of these multiple views. Let us say I have been given two views, x1 and x2, and then I construct one vector comprising of both views. Please do not, let's say, alternating them. Only for representation we are trying to look at this one. That my x1 and x2 essentially are the concatenated in terms of, let's say, in a much more loose sense, but in a notational setting. So x1 essentially the this vector, expected value of this vector is in terms of this one. This mu is in this terms, written in this terms. Now I try to compute once again the same thing, that now I have this vector x and then its mean I have computed. I try to compute the covariance matrix for this vector. That's what I will try to do, that one. Covariance matrix I try to compute. this is the covariance matrix that I have, and it is in terms of multiple views. Now you look at so the covariance matrix having only view, first view, covariance matrix only second view. But this is the one which is of interest. This is the covariance matrix of involving view 1 and view 2, and similarly this is the covariance matrix involving view 2 and view 1, which are both are symmetric, right? And in PCA we try to maximize, let's say, obtain the eigen values and eigenvectors of these covariance matrix, but here we try to do something differently, right? So now in the canonical correlation analysis, what we wanted to do is that we try to maximize the cross covariance, which means that we wanted to have two directions along which we wanted to project the data such that these two directions have maximum correlation, which means I will intuitively try to explain you this figure. Along this direction I have one vector. I have done the linear transformation, and along which I have another vector that assuming that this thing. Now I wanted to maximize the covariance between these two things. That's exactly what we were trying to do in this canonical correlation analysis, right? So over here, what we'll essentially have is that maximize the covariance or correlation coefficient, which essentially is what we have seen through the normalization process. This is what we wanted to maximize in canonical correlation analysis, which means that so now this is the important point I wanted to mention, is that we are finding two directions, direction 1 and direction 2, sorry, direction 1 and direction, here y and x are two directions, and I wanted to find x and y given this covariance matrix involving view 1 and view 2, right? And how I try to do that is that I apply the same trick. I apply the like, and then let's say find its derivative, and then where it will essentially kind of converge. So now I essentially see that I have the value of x to be this form, value of x to be this form, and I through this one I will actually kind of solve this equation, which essentially is nothing but which will give me both x and y in the linearly transformed directions. So I'm just skipping the details. We can actually work out these details, and also I can share you the reference textbooks of multivariate analysis from where you can actually go through this one. But how using these x and y, how this information retrieval actually happens? That's exactly what we wanted to look at it, and I'll show you through this figure. Then you will be able to understand. Is that so? I have first view as the text, the second view as the image, third view as the video, and each of these things have different features. Text has TF, IDF, LDA, or whatever it might be. Image, so is the image in its own representation, video in its own representation. Using all these things, you build a common subspace. That's what is the main thing over here. That's what is the main thing over here. We wanted to build a common representation. And once you build the common representation, we have the cross-modal retrieval, which means that let me just go to a figure where I can, which means that the image has its own image spaces. Image in the, let's say, three-dimensional space essentially is a point over here. This is one point, this is another point, this is another point in image space. In the text space, it is the point in these three-dimensional things. So these are two distinct things. But in the common subspace, text is represented as this point, image is represented as this point. Text is represented as image is represented as this point. Text is represented as this point. and so on and so forth. Now we brought both images and then the text in the common subspace. Now if you give me a query and then say that retrieve all the images, I will try to see that to this text data point, this query text data point, which are the neighborhood images. I will retrieve that. That is the underlying principle in the cross-modal information retrieval, right? And using this one, there are multiple ways in which this cross-modal information retrieval are used. And I'll just try to kind of elaborate you through various ways in which these are all used. They're all used in, let us say, real world representation, real valued representations, which means that this space, whatever this space that we have built, are all real values, or it can be, let's say, binary values. Real valued or binary valued. In the real valued, we'll have unsupervised learning methods, pairwise learning methods, ranking based methods, supervised learning methods. What we have discussed is unsupervised learning algorithm, and that too, let's say, canonical correlation. One of the methods that we had tried to introduce. And if you are interested, you can actually look at many more methods, many more partial least square methods, bilinear mapping methods, the common factor analysis method, and so on and so forth. Innumerable methods are there. And let's say those who are very much motivated from the perspective of the deep learning methods, multiple view learning methods and then cross-modal retrieval are all also applied in the deep learning context. And these are all the state-of-the-art deep learning models for multi-view learning methods. And these are the state-of-the-art methods that are employed in the today's cross-modal retrieval analysis. And I could actually only touch upon very basically and very briefly the underlying mathematical derivations of each of these things. And you can actually kind of take this as the starting point, and then maybe you can go forward. That's what I wanted to say. And then I really thank all the organizers for giving me this time, Dr. Ranbir, Professor Sukumar Nandi, ISEA team, and all others. Thank you. If you have any questions, I will take questions.
Yeah, thank you, Sardi, for giving these very fundamentals and mathematical visualizations of these multi-view and projecting this into the multimodal environment. Yeah, it is very nice talks. So if we have questions, maybe one or two questions we can take from the audience. Participant, if you have a question, you can please post in the chat.
Otherwise, they can ask make ready questions, and tomorrow they can put in the chat again.
Yeah. So, Sardi, just one more request. So, some of the participants are interested in understanding, like say this mining data from like sports-related data. So, if you can also give some lights on that, your commentary mining problems. And that.
So that I will explain in tomorrow's talk, where I will actually take one example of cricket text commentary and what all mining tasks can be formulated using this mining text commentary. That's what I will try to do. That one.
Yes. So
tomorrow I will definitely attend to this
one. With this, so thank you, Sardi.
Thank you.
So I just want information to the participants. I just want to briefly highlight what are the say tomorrow's sessions. Tomorrow we have 2 sessions in the morning and lab sessions in the afternoon. So for the for the lab sessions,